Fermi Paradox. The Fermi Paradox is one of the most famous mysteries in science. It asks a haunting question: if intelligent alien life is possible and likely, why haven't we seen any evidence of it? But there's a version of this paradox that applies not to aliens, but to time travelers. It goes like this. If time travel becomes possible at any point in the future, and humans, or any civilization, learn to move backward in time, then why aren't we being visited by them right now? Why hasn't anyone from the year 3000 appeared on live TV? Why no tourists from the heat death of the universe, coming back to see the simpler times of the 21st century? It's the same shape as the original Fermi Paradox. Only instead of looking outward into space, we're looking backward into time. If it's possible, even once, then shouldn't we be drowning in paradox-proof travelers? Historians, scientists, war criminals, curators of extinct species, even pranksters from the future, bored of their perfect timeline. But nothing. No signs, no evidence, no visits. So what's stopping them? There are few theories, and each one opens its own kind of time paradox. Time travel isn't possible. The simplest answer. Just like some say we haven't seen aliens because interstellar travel is impossible, maybe time is too rigid to be manipulated. No wormholes, no machines, no paradoxes, just a one-way arrow. But this creates a contradiction with some of our best physics, which allows, at least mathematically, for closed time like curves, wormholes, and even quantum time loops. If the laws allow it, why isn't it happening? Tav. The past is read-only. Maybe travelers from the future are here, but they can't interfere. They observe, record, gather data, but never leave a trace. This is like cosmic anthropology. Time tourists might visit, but under strict rules not to touch anything. No interaction, no disturbance. But that raises a paradox of probability. If billions of future humans eventually gain time travel, and even a tiny percentage break the rule, why haven't we seen one mistake, one photo, one glitch, one whispered word that doesn't belong? Third, we're in a quarantine timeline. What if there are multiple timelines, and this one's been locked off? No entry, no exits. Maybe our timeline is a kind of simulation, or a protected zone where outside interference is forbidden. This ties into theories of the multiverse or many worlds interpretation. Time travelers don't come here because they can't, or because this version of reality isn't on the tour map. If true, this means we live in a sealed universe, a version of time created for observation, not interaction. Or they're already here, but we don't recognize them. Maybe the visitors have no interest in revealing themselves. Or maybe they're so advanced, so different, that we wouldn't even recognize them. Think about it. Would a person from 10,000 years in the future look like us? Would they speak our language, use our tools, even need bodies? It's possible they visit as pure information, subtle nudges or changes in probability, not as people in silver suits stepping out of machines. But if that's true, how would we know? How do you detect a whisper in a language you can't understand? 5. Time travel destroys the timeline. The most terrifying possibility. Maybe the reason we don't see time travelers is because every time someone goes back, they break the universe. They cause instability. Paradox loops, contradictions so severe that the timeline self-destructs, resets, or collapses. If so, then we are living in one of the few timelines that hasn't been broken yet. Or perhaps we're the result of millions of collapsed ones. And this version is just stable enough for now. The Fermi Paradox in time travel leaves us with a haunting thought. If time travel is real and the future exists, why are we so alone in the past? Is time protecting itself, or are we already in the ruins of 1,000 failed timelines, and we just don't know it yet? Precognitive Paradox. Precognitive perception is the paradox where your brain reacts to an event before it happens, as if it senses the future, even though no logical signal should exist. This challenges the assumption that all reactions are based on past inputs. In this paradox, the effect comes before the cause, not on paper, but in lived experience. In neuroscience, this idea has been studied through what's called presentiment experiments. In these tests, participants are shown a series of images. Most are neutral or calm, but a few are disturbing, such as violent scenes or graphic injuries. The order is randomized by a computer, and the disturbing images are not predictable. But consistently, researchers have found that participants show physiological changes, like increased heart rate, pupil dilation, or skin conductance, several seconds before the disturbing image appears. Not after. Before. These responses don't occur before neutral images, only before the intense ones, and the participants don't consciously know what's coming. They just react. It seems like their bodies know something before their conscious mind does. A future event causes a reaction in the present. These studies are controversial. Critics argue about methodology, statistical noise, and replication issues, but the data continues to appear, and the paradox remains. Can the brain prepare for something before it happens, without any sensory cue? Now scale that up. Many people report moments in life where they feel something just before it occurs. They pause at an intersection, moments before a car runs a red light. They cancel a trip, and then hear about a disaster they narrowly missed. They sense someone watching them, seconds before turning to see a stranger. Most of these are dismissed as intuition or coincidence. But the paradox remains when we can't find any causal input. If there was no sound, no shadow, no movement, what triggered the reaction? In sports, this edge of perception is sometimes called being in the zone. Elite athletes often report reacting before the action even begins, swinging at a pitch before it's thrown, blocking a punch before it's launched. On film, it looks impossible, but in their minds, it feels like time stretches. As if the future bleeds backward, just enough for the brain to prepare. There's also a growing field of study in anticipatory synchronization, where brain activity appears to align with expected future events, like the moment a musician strikes a note or a runner hears the starting gun. This isn't clairvoyance, it's not supernatural, it's the brain using patterns, rhythms, and internal models to make fast predictions. But if the body reacts before the stimulus, and does so reliably in situations with no logical cue, then where is that signal coming from? Is it buried in the subconscious? Or is time, at some level, not as linear as we experience it? If cause and effect are breaking down, even slightly, in perception, then maybe the present isn't just influenced by the past, but also tugged on by the future. The paradox of precognition isn't just a single thought experiment. It has many disturbing variations, each revealing a different weakness in our understanding of time. One of its most striking forms is what's often called the Bilker's paradox, the idea that if someone tells you the future and you have free will, you'll try to act against it. But if you do change it, then the prediction was never true to begin with. And if you don't, were you ever free at all? This version sharpens the dilemma. It's not just about seeing the future, it's about whether the act of knowing the future makes that future impossible. There's also a deeper twist when the source of that knowledge becomes uncertain, as in the out-of-time knowledge variant. Imagine a person who wakes up with the answer to a question that hasn't been asked yet, or sketches a device they've never seen before, only to find out it doesn't exist yet. The knowledge feels spontaneous, but when traced back, no one, not even the person who received it, knows where it originally came from. It creates a closed loop, knowledge with no beginning, sustained only because it's passed forward. And then there's the physical side, retro-causality, a scientific variation of the paradox that appears in some interpretations of quantum mechanics. In this view, particles in the present might behave in a way that depends on events that haven't happened yet. The future becomes a hidden variable, shaping the now, even before it occurs. Each of these variants pushes the same terrifying question. If we know what's coming, can we escape it, or are we trapped precisely because we tried? Grandfather Paradox. You've probably heard it before, the one where you go back and kill your grandfather before your parent is born. But here's the thing. Most people stop at the question, what if the universe actually allows it to happen? Let's seriously think about it. What happens if you go back in time and kill your own grandfather before your parent was born? If you succeed, your parent is never born. which means you are never born. But if you're never born, then you could never have traveled back in time to commit the murder, which means your grandfather lives, which means your parent is born, which means you exist again and can go back in time to kill him, over and over. Life, death, reset. It's a closed loop, but unlike the Bootstrap Paradox, it doesn't hold together. This loop collapses under its own contradiction. There are only a few ways this can play out, and none of them feel satisfying. Option 1. You fail. Something always stops you. The gun jams. You change your mind. A truck blocks your path. No matter how hard you try, some mysterious force prevents the timeline from breaking. This is called the Novikov Self-Consistency principle. The idea that time is fixed, and any event that would cause a contradiction is simply impossible. The universe won't allow it. But that raises another problem. Do you really have free will in the past? If the timeline must protect itself, are you just a puppet? Option 2. You succeed, and the universe splits. This is the multiverse theory, the idea that every decision creates a new branch. When you kill your grandfather, you don't erase your own existence. You create a new timeline, one where you were never born, but the original you still exists in your own reality. It avoids contradiction, but it also means that your actions in the past are meaningless to your own timeline. You can't change your future. You can only make a new one. Time travel becomes tourism. No matter what you do, you can't go home and see the world change. You just create another branch where someone else suffers. And then there's option 3, the one nobody likes to think about. You kill your grandfather. You blink out of existence, and the timeline doesn't care. No branches, no protection, just erasure. Cause and effect rip apart. Logic breaks. The world continues, missing a piece. Some physicists say this would create a kind of causal explosion, a ripple through time that corrupts everything downstream. Every event that depended on you, or your parent, or even people influenced by them, would collapse. The web of time would tear itself apart. And that's why the grandfather paradox matters. It doesn't just challenge time travel, it challenges how we think about cause and effect. Right now, you exist. You believe your past is locked in place. You trust that what already happened must have happened. But what if you could reach into it, not to observe, but to interfere? That single possibility changes everything. Because if you can change the past, then the present becomes fragile. And if you can't change the past, then the future might already be decided, and you're just acting out your script. Either way, the freedom you thought you had starts to feel like an illusion. The grandfather paradox exposes the most terrifying idea of all. That time might not forgive us. That some actions are impossible, not because they're hard, but because reality itself will collapse if we succeed. And deep down, it forces one more question. The kind we usually avoid. If you had the chance, would you pull the trigger? Butterfly effect consequences. The butterfly effect is often explained as a poetic idea from chaos theory. A butterfly flaps its wings in Brazil, and weeks later, a tornado forms in Texas. But underneath that metaphor is a disturbing reality. Time is not just fragile, it's uncontrollably unstable. This effect isn't just about cause and effect, it's about the impossibility of rewinding time, because in a system as sensitive as reality, there's no such thing as reset. Let's say you woke up this morning 1 minute earlier than usual. You leave the house, cross the street slightly sooner. A stranger, running late for work, almost bumps into you, but you never even notice. He swerves, changes his route, misses the bus he normally takes. That bus now has one fewer passenger. Less weight means it moves a little faster. It arrives at the next intersection just seconds earlier and barely misses a delivery van that would have caused a fatal crash. You'll never know this happened. The people on that van never know how close they came. But one tiny shift in your routine ripples through time, rearranging everything after it. Now, imagine if you could go back to that moment, just to sleep 1 minute longer. To you, it's nothing. But from that point forward, everything changes again. This is where the butterfly effect becomes a time paradox. We like to believe time is like a film strip. We could rewind, snip out a frame, re-edit, play it forward again, and get a better result. But that's not how time works in the real world. Because the second you go back, you're introducing new ripples. You're already part of the system. You're not outside of time. You are tangled in it. That's the trap. Let's take another example. Simple, human, real. You cancel a dinner with a friend at the last minute. They decide to go out alone instead. They meet someone. Years later, they marry that person. They have a child who becomes a teacher. That teacher helps one student through a suicidal crisis. Now rewind. You didn't cancel that dinner. None of it happens. And you'll never know. The paradox isn't just that small things cause big changes. It's that in a timeline you can never return to the same state, because every return creates a new reality. And the more you try to fix, the more unstable it gets. This idea is at the heart of countless time travel stories. In Ray Bradbury's classic tale, A Sound of Thunder, a man steps on a butterfly while on a time travel safari to the distant past. When he returns to the present, the language, politics, and even people have changed. The past was altered, but not in the way he expected. It's not dramatic at first, but it's irreversible. And in the real world we experience this in smaller, quieter ways. Text you almost didn't send. A seat you almost didn't take. A mistake you thought was trivial, that led to a chain reaction you couldn't control. The butterfly effect becomes a time paradox. When we realize this, there is no go back and try again. Because the moment you go back, you are already creating a new future, and the original one is lost. Even trying to undo something becomes an action that adds to the system, and that action cannot be undone. So we are left with a terrifying truth. In a universe this sensitive to change, you never really know what moment your life turned, and you'll never be able to find it again. Twin Paradox. The twin paradox is a thought experiment in physics that reveals a strange consequence of Einstein's theory of special relativity. Time moves differently depending on how fast you're moving. It begins with two identical twins. One stays on Earth. The other boards a spaceship, accelerates to near the speed of light, travels through space, and then returns. According to Einstein, time slows down for objects moving at high speeds, a phenomenon called time dilation. So when the traveling twin returns, they are younger than their sibling, maybe by a few minutes, maybe by decades. It depends on the speed and duration of the journey. This isn't science fiction. It's a real effect that's been confirmed experimentally. In 1971, physicists placed synchronized atomic clocks on jet planes and flew them around the Earth. When compared to identical clocks left on the ground, the flying clocks had ticked slightly slower, exactly as predicted by relativity. Saint-Claude swapped that effect up to interstellar speeds. If one twin travels to a distant star at near light speed and returns, only a few years might have passed for them. But decades could have passed on Earth. They left as equals. They returned as a stranger. This is why it's called a paradox, not because the math doesn't work, but because the outcome defies everyday intuition. We expect time to be constant, but in relativity, time is elastic. It stretches and compresses depending on motion. To most people, the paradox feels like a contradiction. If motion is relative, then each twin should see the other as moving. So why doesn't each twin think the other one is aging slower? The answer lies in the asymmetry of the situation. The twin on Earth stays in an inertial frame, constant speed, no acceleration. The traveling twin accelerates, turns around, and decelerates. These changes break the symmetry. Acceleration changes how space-time flows around you. And the moment the ship turns back toward Earth is where the timelines diverge. The paradox shows us that time is not universal. It depends on your path through space-time. Two people can share the same starting point and destination, but live through very different amounts of time between them. And what makes this even more unsettling is that it's not just about clocks or physics labs. This effect applies to conscious experience. If a person left Earth, traveled at near light speed for what felt like 2 years, and came back, their friends might be gone. Their family aged, their home changed. They didn't just lose time, they moved through it differently. And it wasn't a dream. It wasn't a trick. It was the real, measurable bending of time itself, written into the structure of the universe. This paradox opens up variations, some subtle, some mind-breaking. One variation is often separated out: time dilation. It's the underlying mechanic, the fact that time slows down when you move close to light speed. And this isn't just a theory. We've measured it. Muons, particles created in the upper atmosphere, live longer when they're moving fast. GPS satellites, orbiting the Earth, need constant adjustments because their clocks tick at different speeds than ours. Time dilation isn't fiction, it's infrastructure. But the twin paradox asks a deeper question. Why does only one twin age less? After all, from the traveler's point of view, isn't Earth the one that's moving? This leads us to another variation, the simultaneity paradox. In Einstein's theory of relativity, simultaneity, the idea that two events happen at the same time, isn't absolute. It's relative. Depending on your speed and frame of reference, what is now for you is later or earlier for someone else. So when the traveling twin turns around to return, their frame of reference shifts and their definition of now on Earth jumps forward suddenly. This moment, the turnaround, is the key. It's not just about speed, it's about acceleration. The traveling twin feels the change. The earthbound twin does not, and it's that change in perspective that explains the asymmetry. They're not experiencing the same time from different views. They're in different realities of time altogether. This isn't just physics, it's a shift in how we think about aging, distance, and the meaning of when. In the twin paradox, the universe isn't broken. It's working exactly as it should. We just weren't built to feel it. And yet, it leads to the haunting truth. If you move fast enough, you can leave people behind, not just across space, but across decades. A journey to a nearby star might take a few years for you, but by the time you come back, the world you knew may be long gone. Photonic timelessness. Imagine a beam of light leaving a distant star. It travels for billions of years across the black ocean of space. Eventually, it reaches your eye, or a telescope, or a satellite. You'd say it took forever to get here, that it lived a long journey. But ask the photon, and it would say, I was emitted and absorbed at the same time. This is the paradox of photonic timelessness, a window into the reality that time is not universal. According to special relativity, as an object approaches the speed of light, time slows down for it. Not just a little, dramatically. At the speed of light, time doesn't just stretch, it stops. For a photon, there is no before or after. There is no past, no duration, no aging. It leaves a source, arrives at a destination, and from its point of view, it never existed in between. This becomes even stranger when paired with a quantum-level paradox, the timeless quantum state. In quantum mechanics, the fundamental equation that describes how a system evolves, the Schrödinger equation, includes time. But there are formulations, especially in quantum gravity, where time doesn't appear at all. The system just exists. It's not moving, not developing, just being. This leads to an unsettling question. Is time something real, or just something we experience when we're slow enough to need it? Because when you speed up to the universe's limit, the speed of light, time disappears. Your entire journey happens in a single point. No waiting, no change, no moment-to-moment experience. But you don't have to be a photon to feel this. Some people experience flashes of this state during near-death experiences or deep meditative states. Time collapses. The beginning and the end blend into one. Some describe seeing their entire life at once. Others say there was no sequence at all, just an overwhelming sensation of total presence. So now the paradox deepens. We think of time as movement, change, cause, and effect. But photons, the particles that make vision itself possible, experience none of it. From their perspective, they don't travel. They connect 2 points in space instantly, which means light isn't illuminating the world in time. It's threading time together from the outside. And if that's true, then maybe time, as we experience it, is a slow illusion, meant only for the beings who can't outrun it. Novikov Self-Consistency. The Novikov Self-Consistency principle is a time travel theory that says you can't change the past because any attempt to do so was already part of it. It's not just a theory about limits, it's a theory about inevitability. If you travel back in time, your actions might feel like choices, but they've already happened. They were always supposed to happen, and they can't create a paradox because they're already part of history. The principle was proposed by Russian physicist Igor Novikov in the 1980s, and it was designed to solve one specific problem in time travel: what stops you from causing a contradiction, like going back to prevent a war or saving someone who was always meant to die. Under this principle, the answer is simple: you won't succeed. Not because you're not trying hard enough, but because any attempt that would violate causality will be blocked by the universe itself. And strangely, this doesn't require any mystical force or divine intervention. It just means the timeline is self-consistent. If an event didn't happen in the past, then your future time travel actions couldn't have changed it. One of the clearest examples comes from a short story called By His Bootstraps, written by Robert Heinlein in 1941. In the story, a man is pulled into a time travel loop where he meets multiple versions of himself, one older, one younger. Each version pushes the next into the loop, but every step he takes to understand or escape the situation only leads him further into it. He eventually becomes the very person who manipulated his younger self. He tries to make different decisions. He believes he's acting freely, but everything he does simply fulfills what already happened. That's the Novikov principle in action. It doesn't stop time travel, it just prevents contradictions. Whatever happened, happened. You're not rewriting history. You're part of the original script. And this idea isn't limited to fiction. In theoretical physics, the Novikov principle has been used to explore what might happen near wormholes, structures in spacetime that could, in theory, allow for travel between different points in time. Researchers like Kip Thorne have examined whether closed time, like curves, paths through time, that loop back on themselves, could still obey self-consistency. One famous thought experiment is called the Polchinski paradox. It goes like this. Imagine a billiard ball rolling toward a wormhole. If it enters the wormhole, it emerges in the past and hits its earlier self, knocking it off course so that it never enters the wormhole in the first place. That creates a contradiction. But under the Novikov principle, something else happens. The ball might still go through the wormhole, but this time, when it emerges in the past, it nudges its younger self in just the right way to ensure that it still enters the wormhole. No contradiction, just a strange, looping form of causality. And once you accept that logic, the consequences get darker. You can go back in time. You can interact, but no matter how hard you try to change things, you'll only cause the events you were trying to prevent. This idea has many layers and multiple variants that reveal just how aggressive the universe might be in protecting itself. Take, for example, the chronology protection conjecture introduced by Stephen Hawking. It proposes that the very laws of physics might act like a firewall, preventing time travel altogether, especially into the past. Every time someone tries to build a time machine, reality intervenes, the energy diverges, the tunnel collapses, the device melts down. Not by coincidence, but by design. The universe, Hawking said, hates closed time like curves. It doesn't just passively allow the past to exist, it protects it, like an immune system attacking a virus of contradiction. But Novikov's version goes deeper. It says the paradoxes don't need to be blocked because they can't occur in the first place. Even if you do go back, even if the machine works, you will only be able to do the things that already happened. You can try to kill your grandfather. The gun will jam. You'll trip. He'll be wearing a bulletproof vest. No matter how you act, the outcome will fold itself into the timeline you already came from. Some physicists have explored this using billiard balls and wormholes. Imagine a ball sent through a time tunnel to collide with its past self, a direct paradox. But in every consistent simulation, the collision changes the ball's path just enough to cause the same entry angle. The loop remains intact. The paradox erases itself, not because it didn't try to form, but because it never could. And this brings us to a psychological variation, the temporal resistance paradox. This version isn't about machines. It's about people trying to change their past. A time traveler goes back to stop a tragedy. No matter what they do, it happens anyway. They act sooner. The outcome shifts, but something always adjusts to bring the timeline back on course. Like fate wearing different clothes. Some versions get darker, suggesting the harder you try to change the past, the more your actions become the cause of the very thing you hope to undo. Novikov says, events are self-consistent, but what if the reason they are is because the timeline pushes back? This principle creates a terrifying world. You can travel, observe, even act. But your actions are already part of the past. Your freedom becomes a script, and your choices, illusions that were always meant to happen. The paradox doesn't explode, it collapses into inevitability. Bootstrap Paradox. You write a book, it becomes a bestseller. Years later, a fan hands you a copy and says, "This changed my life." You flip it open, it's your handwriting. Every word, every diagram. But you never wrote this version. You copied it from this exact book 20 years ago, when someone else handed it to you. So here's the question, who actually wrote it? Welcome to the Bootstrap Paradox, one of the strangest, most disturbing time paradoxes ever imagined. It's called bootstrap because the object pulls itself into existence, like lifting yourself off the ground by pulling your own shoelaces. Impossible in real life, but strangely allowed in time travel scenarios. Let's look at a classic example. A scientist finds blueprints for a time machine. They're detailed, complete, and in her own handwriting. She doesn't remember creating them, but she uses them to build the machine. It works. She travels back in time and gives the blueprints to her younger self. Now the loop is closed. The blueprints exist because they were passed along. But no one ever invented them. They were never created, only transferred. That's what makes this paradox so strange. It doesn't cause a contradiction. The timeline works, but the object, the blueprint, has no origin. It wasn't made, it just exists. This kind of loop isn't just theoretical. Some physicists think it could actually happen. According to general relativity, certain types of time loops called closed time-like curves are mathematically possible, especially near black holes or wormholes. These curves would allow objects to move in a loop through time, returning to the same point over and over. In that kind of universe, bootstrap paradoxes wouldn't break physics. They'd be expected, and it gets stranger. This isn't just about objects. It can happen with information, or even people. There's a famous science fiction story where a baby is left at an orphanage. She grows up, becomes a soldier, is injured, and undergoes gender reassignment surgery to become male. Years later, he goes back in time, meets a young woman, and she becomes pregnant. The baby is left at the orphanage. That child, the parent, and the lover are all the same person. It sounds insane, but the logic is closed. There's no contradiction. It just forms a perfect loop. And here's the disturbing part. There's no way to tell if something is part of a loop, a song, a quote, a scientific discovery. If someone found it in the past and passed it to the future, and then someone brought it back again, it might keep looping forever. No one creates it. It simply exists. This breaks everything we believe about how the world works. We think ideas come from somewhere. We believe every invention has a creator. But the bootstrap paradox suggests that some things don't. They're caught in a time loop, self-contained, without origin. And if this is possible, then even you could be part of a loop. A memory in your head, a sentence, a dream, a formula might not be yours. You might be repeating something that was never created at all. The worst part is, there's no way to know. The universe doesn't label these things. It doesn't say, this has no origin. To everyone inside the loop, everything looks normal. The bootstrap paradox isn't a standalone puzzle. It has many twisted siblings. They all orbit around one impossible question. How can something exist without ever being created? One of the most mind-bending variations is known as the ontological paradox, which focuses on the origin of information or identity. Imagine a scientist who receives blueprints for a time machine from her future self. She builds it, uses it, and eventually goes back in time to deliver those same blueprints to her younger self. The machine exists. The information exists. But who invented it? There's no answer. It just loops forever, with no beginning. The origin isn't lost. It never existed. Then there's the broader framing, the causal loop. In this structure, events form a closed circle. Each action causes the next, and eventually loops back to cause the first. But the loop isn't about one object. It's about entire sequences of events, memories, motivations, histories, all locked in a recursive spiral. Think of a man who discovers a mysterious book that tells the story of his life. He lives that life, writes it down, and passes it on as the same book. The actions are different from objects, but the logic is identical. The cause and effect support each other endlessly, with no ground beneath them. And then there's the recursive artifact paradox, a variation where an object, rather than a person, has no point of creation. Picture this: a musician finds a strange composition in a drawer. Inspired, she performs and records it. Years later, someone from the future hears it, goes back in time, and places that same sheet music in her drawer, the one she originally found. The music exists. It was written, but by whom? No one. It's trapped in a causality loop, a recursive artifact, like a ghost playing ping-pong with itself through time. Even the predestination paradox, which is sometimes treated separately, can be seen as a personal variation of the bootstrap. In it, someone travels back in time to prevent an event, only to cause it, but over time their actions become indistinguishable from the original history. It's not just that they failed to change the future, it's that they became the reason it happened at all. Like someone trying to stop a fire, only to become the spark they were trying to extinguish. Each version carries a different emotional weight. The bootstrap leaves you stunned. The ontological version leaves you confused. The predestination variation leaves you haunted. The more you chase the origin, the further you fall into the spiral. Because in this paradox, there is no beginning. Reverse memory paradox. The reverse memory paradox describes a scenario where an individual remembers the future instead of the past, flipping the normal direction of memory and challenging the very structure of cause and effect. In our world, memory is tied to entropy, the idea that time moves forward because disorder increases. We remember the past because it has already happened. We don't remember the future because it hasn't. But there's nothing in the laws of physics that strictly forbids memory from flowing the other way. The equations that govern motion, from Newton's laws to the Schrödinger equation, are time-symmetric. They don't care if time runs forward or backward. This raises a paradox. If the laws of nature allow time to flow in both directions, why does our memory only point one way? And what happens if it doesn't? Imagine a man wakes up with full, vivid memories of tomorrow. He knows conversations that haven't happened yet. He can describe headlines that won't be published until next week. He avoids accidents, finishes projects before they're started, and knows what people will say before they speak. But he remembers nothing from yesterday. His knowledge of the past is blank. To him, the direction of time is flipped. Memory flows backward. He lives as we do, but in reverse. And to him, we are the ones who forget everything the moment it happens. This idea appears in literature and philosophy, most famously in Martin Amis's novel Time's Arrow, where the entire narrative unfolds in reverse. The main character perceives time backward, watching people undie, food return to plates, and destruction undo itself. In the story, actions feel normal to the character, but horrifying to the reader, because our memory runs the other way. This paradox is also explored in discussions of the psychological arrow of time, the reason we feel time moving in a particular direction, even though physics doesn't require it. One explanation ties memory to entropy. As entropy increases, we record changes in the environment, and those records become memory. If entropy decreased instead, maybe we'd remember the future, not the past. But if someone did remember the future, would they be seeing what's inevitable? Or would their memory be fragile, like a guess that feels certain, but keeps shifting? And if two people remembered opposite directions, one remembering forward, the other backward, how would they ever agree on what just happened? The paradox challenges the link between time and awareness. It forces us to question whether memory is a record of truth or just a survival mechanism built to follow entropy. Zeno Time Paradox. The Zeno Time Paradox in quantum mechanics suggests that the more closely you observe a quantum system, the slower it appears to evolve, to the point where it may never change at all. This effect is sometimes called the quantum Zeno effect, and it's named after the ancient philosopher Zeno of Elea, who proposed logical paradoxes about motion, like an arrow that never moves, because at every instant it's frozen in place. In quantum physics, a similar problem appears, not as a thought experiment, but as a real phenomenon. Here's the idea. In the quantum world, particles like electrons exist in states of probability. They aren't in one defined position or condition until they're measured. When you observe them, their wave function collapses, meaning they pick a definite state. But if you measure a quantum system very frequently, you reset its evolution each time. It never gets the chance to change because it's constantly being collapsed back into its initial state. It's like asking a question every millisecond, and every time you ask, the system is forced to answer, "I'm still the same." This was confirmed in laboratory experiments. In one case, scientists prepared atoms in a known quantum state and used rapid-fire laser pulses to ask whether the atoms had decayed to another state. The more frequently they asked, the less likely the atoms were to change. When observed continuously, the decay almost completely stopped. Time, in effect, froze, but only because of observation. This seems to violate our normal understanding of causality. We expect systems to change as time passes. But in the quantum world, the passage of time is tied to whether or not we're watching. This creates a paradox. If measuring a system prevents it from evolving, and evolution is what defines time, then constant measurement stops the clock. Unlike classical Zeno paradoxes, which are philosophical and abstract, the quantum version is testable and real, and it challenges the idea that observation is passive. In quantum mechanics, observation isn't just a way to see the world. It changes the world. This raises difficult questions. What counts as a measurement? Is it the human observer, a detector, a field interaction? Where is the line between watching and interfering? And if time itself can be halted just by checking in too often, then what does it mean for time to flow at all? Temporal stasis loop. A temporal stasis loop is a situation where an event, or sequence of events, repeats in time indefinitely, with no forward progression. Unlike other time loops where a person resets to an earlier moment, a stasis loop traps people, objects, or thoughts inside a frozen pocket of time, looping endlessly. Nothing ages. Nothing evolves. There's no memory of what came before. From the inside, everything feels normal. From the outside, nothing changes. This isn't about going back. It's about being stuck, permanently. In fiction, one of the best-known depictions comes from Star Trek: The Next Generation, in the episode Cause and Effect. The starship Enterprise is caught in a time loop, endlessly repeating the same events. Every time, the ship explodes. And every time, the crew unknowingly starts the sequence over again, trapped in a temporal bubble that resets the moment before death. Eventually, subtle differences build up, and one of the characters begins to suspect something is wrong. Tiny memories leak through. That's how they escape. But in most versions of the temporal stasis loop, there is no escape. Here's a thought experiment. Imagine a man trapped in a room with a single phone. Every day at 9:00 a.m., it rings. He answers it. He hears a voice, his own, telling him what will happen over the next 24 hours. Every word turns out to be true. Every event plays out exactly as described. At 9:00 a.m. the next day, the phone rings again. The same voice, the same message, the same day. Again, he has no memory of making the call, but he believes it because it's always right. The loop is closed. Not by time travel, not by paradox, but by a feedback loop of information, sealed and replayed forever. This is what makes a temporal stasis loop different from other time-related paradoxes. There's no contradiction, no attempt to alter the past. There's only a perfectly self-sustaining system where time flows in a circle so tight it becomes a prison. In theory, certain solutions in general relativity allow for this. If time is treated as a dimension that can curve and fold, then a localized region of space-time could potentially cycle endlessly, disconnected from the timeline around it. Think of it like a scratch on a record. The world plays normally until it hits the scratch. Then it loops. From the outside, it looks like nothing is happening. From the inside, it feels like life. This idea isn't just science fiction. It has implications for memory, perception, and identity. If you lived the same day repeatedly and didn't know it, would anything about you actually exist beyond that moment? And what if someone else placed you in that loop? What if the voice on the phone was your future self, trying to keep you safe by making sure nothing ever changes? The elevator that changed history. Secretivator gravitational time dilation is a consequence of Einstein's general relativity that states the stronger the gravitational field you're in, the slower time moves for you compared to someone farther away from that gravity. This means that time itself runs differently depending on how close you are to a massive object like a planet, a star, or a black hole. The deeper you are in a gravity well, the more your time slows down. This effect is measurable. In one famous experiment, two identical atomic clocks were placed at different altitudes, one on the ground floor of a building, the other on the top floor. After a period of time, the clock at the top had ticked slightly faster than the one below. The difference was tiny, nanoseconds, but real. The closer clock was deeper in Earth's gravity, and time had slowed for it. The elevator ride between those floors had changed the passage of time, literally. And this is not limited to buildings. The stronger the gravity, the more extreme the effect. Near a black hole, gravitational time dilation becomes severe. If you orbited close to its event horizon, the point of no return, time for you could slow to a crawl compared to someone far away. Minutes for you might equal years for them. This was dramatized in the film Interstellar, where a planet near a black hole experiences time at a drastically slower rate. The science wasn't perfect, but the core idea was correct. A few hours on the surface could equal decades back on the ship. That kind of distortion isn't just theoretical. It's built into the equations of general relativity, and we account for it every day. Satellites in orbit, including those used for GPS, tick at different rates than clocks on Earth, not only because of motion special relativity, but because they're farther from Earth's center of gravity. If we didn't adjust for this time dilation, GPS locations would drift and become inaccurate very quickly. So even though we live in one continuous world, we don't live in one continuous clock. Time flows at different rates depending on where you are, even in everyday situations. Gravity doesn't just bend light or pull objects, it bends time. And in the deepest gravity wells in the universe, time can become so distorted that it almost stops. The black hole clock. A black hole is a region of space where gravity is so strong, not even light can escape. But one of the strangest effects of black holes isn't what they do to matter, it's what they do to time. According to general relativity, as you approach the event horizon, the invisible boundary around a black hole, time slows down dramatically for you compared to someone far away. This is an extreme version of gravitational time dilation. The stronger the gravity, the slower your time. And at the edge of a black hole, gravity is at its maximum. From your point of view, everything feels normal. Your heart beats, you blink, you move. But for someone watching from a distance, your motion appears to slow and then freeze entirely as you approach the horizon. They'll never see you cross it. To them, you freeze in time, forever hovering just above the edge. This isn't a visual illusion. It's a real consequence of how space-time behaves near a black hole. If you could hover just outside the event horizon, somehow resisting the pull, you would experience time at a fraction of its normal speed. 1 minute for you might mean years, centuries, or even longer to someone observing from Earth. In theory, you could wait near a black hole and witness the far future unfold in moments. Watch civilizations rise and fall. See stars burn out. Experience the end of the universe in what feels like an afternoon. This idea forms the basis of multiple science fiction scenarios, including the film Interstellar, where characters orbit near a black hole called Gargantua. Due to the intense time dilation, a few hours spent on the surface of a nearby planet results in 23 years passing on their main ship. The numbers are exaggerated, but the physics is real. Black holes don't just trap light, they trap time. What we call an event horizon isn't just a spatial boundary. It's a temporal edge, where the flow of time itself slows to nearly zero from the perspective of an external observer. And while you might feel like you're falling normally, to the rest of the universe, your clock stops ticking. From that vantage point, you become a statue, frozen in time, on the edge of forever. Neutrino time reversal. In particle physics, there's a strange idea connected to one of the most elusive particles in the universe. The neutrino. Under certain interpretations of quantum field theory, a neutrino might not just move forward through time like everything else. It might actually be a mirror of a particle moving backward in time. This leads to what's sometimes called the neutrino time reversal paradox. Neutrinos are subatomic particles with almost no mass, no electric charge, and the ability to pass through matter almost undisturbed. Billions of them are moving through your body right now, without a trace. They barely interact with the world, but they may interact with time in a very unusual way. The idea comes from a strange symmetry in physics called CPT symmetry, short for charge, parity, and time. According to this principle, the laws of physics should remain the same if you flipped three things at once. Charge turning matter into antimatter. Parity flipping left and right, like a mirror image. Time running the process backward. If you reverse all three, the equations still work. Now here's where neutrinos become unusual. Some theoretical models suggest that an antineutrino might be indistinguishable from a neutrino traveling backward through time. It's not just poetic language. Mathematically, flipping a neutrino's properties according to CPT symmetry can make it behave exactly like its antiparticle, only in reverse. This creates a strange possibility. A neutrino might be its own opposite, depending on how it moves through time. It's not confirmed, and it's still debated. But this hypothesis is tied to a deeper mystery. Why do we see more matter than antimatter in the universe? If particles like neutrinos violate time symmetry in subtle ways, it might explain why the early universe evolved into a matter-dominated world instead of annihilating itself into nothing. Experiments like those conducted at the Super Kamiokande detector in Japan and others around the world are actively studying neutrino oscillations, how neutrinos change types or flavors as they move, to look for signs of time reversal asymmetry. The results so far hint that neutrinos may not behave identically when time is flipped, unlike most other particles. And if that's true, it suggests that time is not symmetric at the most fundamental level, and that the universe has a preferred direction. This is where the paradox forms. If a neutrino is its own antiparticle, and possibly moving backward in time depending on how it's observed, then how do we define its origin? When does its journey begin or end? And are we observing the effects of something that hasn't happened yet? Neutrinos aren't just fast, they might be moving differently through time itself and hiding a deeper asymmetry in the universe that we've only just begun to detect. Tachyon causality violation. In theoretical physics, a tachyon is a hypothetical particle that always moves faster than light. If such particles existed, they would not just be fast, they would violate causality. The paradox is simple. If something travels faster than light, it could arrive before it even started. This is known as tachyon causality violation, and it collapses the normal flow of cause and effect. According to Einstein's theory of relativity, the speed of light is not just a speed limit, it's the boundary between what we can consider the present and the future. Nothing with mass can accelerate past it. But tachyons, if they exist, would be born on the other side of that barrier. They would always move faster than light and could never slow down to sublight speeds. And that's where the trouble begins. Let's say a tachyon is emitted from point A and travels to point B, but because of its speed, it reaches point B before it was emitted. From one frame of reference, everything looks fine. The particle is sent and it arrives. But from another frame of reference, one moving fast enough, the sequence reverses, the particle is received before it is sent. This creates a feedback loop that breaks causality. It allows for messages or events to arrive before the cause that created them. In practical terms, if you could send a tachyon signal, you could potentially send information into the past. That means you could receive a message before you ever decided to send it. This is more than a theoretical curiosity. It destroys the logic of consistent histories, and in a universe where causes can happen after their effects, nothing is stable. To prevent this, most physicists believe tachyons can't exist, or that if they do, they can't interact with normal matter in any meaningful way. In quantum field theory, attempts to include tachyons often lead to mathematical instabilities. The equations blow up. The system becomes unpredictable. Still, tachyons show up in theoretical models. In string theory, for example, the presence of tachyonic fields is often interpreted not as particles, but as signs that a configuration is unstable, like a hilltop that's ready to collapse into a valley. The tachyon is a clue that something is broken, a pointer toward a new lower energy state where the system stabilizes. But the causality problem remains. If anything, no matter how small or subtle, can travel faster than light, even as a virtual particle, even as a quantum fluctuation, then the entire timeline becomes fragile. Effects can loop backward, choices can be overwritten, and reality becomes nonlinear. The idea of a tachyon might never be physically real, but the paradox it creates, of something arriving before it left, forces us to confront how deeply causality is woven into everything we believe about time. Neural feedback loop. The neural feedback loop paradox describes a situation where the brain reinforces a memory or belief, not because it's true, but simply because it keeps replaying it. This creates a kind of internal loop, where the act of remembering becomes the source of truth, even if no original event ever occurred. In this paradox, the brain doesn't store information because something happened, something feels like it happened because it was stored. Neuroscience has shown that memory is not like a file stored on a hard drive. Instead, it's reconstructed each time you recall it, and each recall subtly changes the memory. Neural pathways are reactivated, slightly reshaped and reconsolidated. The more you remember something, the more likely you are to believe it, whether or not it's accurate. Now here's where it gets strange. In some cases, the brain can replay a mental image, sound, or thought so often that it burns itself in, without any real experience behind it. For example, in a well-documented phenomenon called confabulation, people, often with brain injury or dementia, create detailed, vivid memories of events that never happened. They're not lying. They truly believe what they're saying. And the more they recall it, the more confident they become. In one case, a man confidently described spending the day at the beach with his grandchildren, down to the color of the towels and the smell of the sunscreen. But hospital staff confirmed he had never left his bed. The memory was constructed and then looped until it felt real. This also shows up in obsessive-compulsive disorder and certain forms of PTSD. In OCD, intrusive thoughts are not just unpleasant, they become reinforced through repetition. Each time the brain checks if the stove is off or if the door is locked, it deepens the need to check again. The memory of checking is overwritten by doubt, and the brain loops endlessly, not to discover the truth, but to escape uncertainty. In PTSD, traumatic flashbacks behave similarly. A single traumatic event may be replayed in the mind over and over, and each replay cements it further, burning the fear deeper, long after the original danger is gone. This creates a paradox of self-reinforcing reality. A memory doesn't persist because it reflects the past. It persists because the brain keeps looping it. And the loop can begin internally. In some experiments, subjects have been shown random visual patterns or meaningless words, and later asked if they remember seeing them before. When the stimulus is shown repeatedly, even without meaning, people begin to say, "Yes, I've seen this." And eventually, I remember where I saw it. This is the illusory truth effect, a psychological principle where repetition itself increases belief, regardless of accuracy. In other words, the brain begins to record itself, looping signals back through attention, emotion, and recall, until the loop becomes the memory. It doesn't matter if it started with truth. It only matters that it's repeated. This paradox has a close cousin, often called the recursive attention trap. It's what happens when attention becomes its own object. You're not watching the world. You're watching your own watching. And just like a camera pointed at a monitor that shows the camera's feed, the image collapses into infinite echoes. In neurological terms, it's a form of cognitive overfitting. The brain is supposed to filter noise, discard repetition, and keep things moving. But when the loop forms due to trauma, obsession, meditation, or even psychedelics, the feedback strengthens instead of fading. The brain starts responding to its own signals as if they were new input. It begins to echo itself, and those echoes start to dominate reality. Some people report it during anxiety attacks. Time feels like it's repeating. Thoughts won't stop circling. You know you've had this thought already, but it comes back again and again. Others experience it in dreams. You wake up only to realize you're still dreaming. You escape the loop, only to find yourself back at the beginning. A recursive dream inside a recursive dream, endlessly folding inward. It even shows up in artificial intelligence. When reinforcement loops go unchecked, models start rewarding themselves for their own output, spiraling into self-confirming nonsense. The paradox here isn't physical, it's cognitive. You are the observer, but you're also the thing being observed. And when that loop locks in, when thought turns on itself too many times, the system breaks. You no longer know if time is passing. You no longer know if you're remembering, or just remembering the act of remembering. In the neural feedback loop, time becomes irrelevant, because you've trapped yourself inside the mirror. Chrono-Loop Perception. The Chrono-Loop Perception paradox describes a scenario where a person relives the same segment of time repeatedly. But unlike ordinary memory, each repetition feels like a new experience while also being strangely familiar. This is not necessarily a physical time loop. It's a paradox rooted in conscious perception, where the brain cannot tell whether it's remembering the past or experiencing it again. In science fiction, this is known as the Groundhog Day scenario, named after the film where the main character wakes up to the same day over and over, with full awareness of each repetition. But in paradox terms, it's more than just a plot device. It asks, what happens when experience detaches from time's forward motion? And what if awareness itself gets trapped, even when the rest of the world moves on? The paradox becomes especially eerie when memory is affected. Imagine someone who wakes up every day, believing it's the same date. They live through a normal 24 hours. But the next morning, all memory of the previous day is gone, and they start again unaware. To an outsider, the days are moving forward. To the person, they're frozen in one loop. Now reverse it. Suppose the day actually is repeating, the entire universe resetting, but your memory is the only thing that carries over. You remember every detail. Everyone else resets. You're trapped in the loop alone. This creates a paradox of perception. Is time looping because events are repeating? Or is it looping because your mind is? And is it possible to be in a loop without even knowing it, if your memory is erased each time? There are medical conditions that echo this. Patients with anterograde amnesia, like the real-world case of Clive Waring, are unable to form new memories. They believe they've just woken up, every few minutes, for years. To them, life is a loop of fresh awakenings. Time outside their awareness keeps moving, but inside, it's standing still. This shows how fragile our sense of time really is. In this paradox, what repeats may not be the day itself, but the awareness of the day. There's a closely related experience known as subjective time expansion, a paradox where time doesn't repeat, but stretches unnaturally. This happens in car crashes, combat, or moments of terror. 1 second on the clock feels like 10. Your thoughts race, your vision sharpens, and every instant feels amplified. You're not looping, but you're living so much inside the moment that it feels like an eternity. The brain, in both cases, is doing something strange. It's disconnecting your internal time from objective time. Your mental clock starts playing tricks. And once it does, the loop or the stretch can feel more real than reality itself. It's especially terrifying when the loop becomes self-aware. You realize you're in it. You become conscious of the fact that you're repeating something. Then you notice that you're noticing it, and that thought itself becomes part of the loop. You can't tell if you're experiencing time or just re-experiencing your own awareness. Some describe it like watching the same film scene over and over, but with no remote, no stop button, and no way to look away. Only you're both the viewer and the character. You're trapped inside the repetition. And the danger is, once your perception becomes unreliable, how can you ever trust that time is moving at all? Chrono-Loop Perception doesn't ask what time is. It asks something worse. What if time only feels real when your mind behaves? Memory shaping reality. In Memory-Created Reality Paradox explores the idea that your sense of the past may not come from experience, but from memory created after the fact. In this paradox, the memory doesn't record the past. It invents it. Your brain constructs a version of what just happened, then convinces you that's what you lived through. In everyday life, we trust memory to be a record of reality. We assume we remember things because they occurred. But research in neuroscience shows that memory is not a playback system, it's a reconstruction engine. Your brain doesn't store experiences like a video camera, it pieces them together after the event, filling in gaps, smoothing over inconsistencies, and sometimes inserting information that was never there. One well-documented phenomenon is the false memory effect, where people confidently recall events that never occurred. In controlled experiments, researchers have been able to implant entirely fabricated memories using carefully worded suggestions or doctored photos. But the paradox becomes more disturbing when you realize this can happen immediately, not just with old memories but with events that supposedly occurred seconds ago. For example, in change blindness experiments, subjects fail to notice massive changes in a scene, such as a person's clothing or even their identity, because their brain fills in what it expects rather than what it sees. Afterward, when asked what happened, people often describe a consistent, logical story, but it's a story that was built by their brain after the moment passed, not during it. Now imagine this applied on a larger scale. You wake up from a dream, but the dream included not just surreal images, but an entire history. Memories of events you never lived, relationships you never had, problems you never solved. And upon waking, you feel certain those things were part of your life. There's no way to prove they weren't, because now they exist in your memory. In extreme cases, this can happen during fugue states or dissociative episodes, where people report waking up with fully formed backstories that contradict their actual lives. Their minds didn't record a new reality. They wrote it. This paradox suggests that reality as we know it might be stitched together after the fact, with memory shaping what we believe the past must have been. This becomes terrifying when we consider its related variant, the experiential gaps paradox. In this variation, time does move forward, but your mind skips over parts of it without telling you. Moments vanish. You walk into a room and don't remember why. You finish a conversation, but forget the beginning. Not because the information was unimportant, but because your brain deleted it before you could ever notice. This isn't just forgetfulness. It's timeline reconstruction. Your mind doesn't leave the gap empty. It fills it in with guesses, with fragments, with fiction, and those invented memories become just as real to you as the truth ever was. In extreme cases, it mimics the sensations of time loops or frozen time. A person might feel they've lived the same hour twice, or sense they've lost a day, and reality just continued without them. Their memory says one thing, true. Their calendar says another, and they have no way to resolve the conflict, because the only tool they have to detect time is the thing that's breaking. Think about how often we measure time emotionally. That weekend felt like it flew by. That meeting dragged on forever. I swear this happened already. All of these are symptoms. your perception of time is being rewritten, not by clocks but by memory deciding how much something mattered. The deeper danger is this: when memory distorts time, it doesn't feel wrong. It feels normal. It feels true. And that means you could be living a carefully edited version of your life, skipping pain, smoothing trauma, amplifying joy without your consent. In the paradox of memory shaping reality, time doesn't build you. You build the timeline. And once you realize that, you might never trust your memories again. Quantum observer time link. In classical physics, time is just there, always ticking, always moving. But in the quantum world, time isn't so obedient. This paradox asks a terrifying question. What if time doesn't exist until you observe something? At the heart of quantum mechanics is the measurement problem. The idea that a particle exists in multiple states at once until it's measured. This is called superposition. A particle doesn't have a definite position, speed, or energy, just a cloud of probabilities. But the moment someone measures it, the wave function collapses. It becomes real. It chooses. It commits to one outcome. Now imagine this. What if the same thing happens to time? Before the observation, the particle wasn't just undefined in space, it was undefined in time. It wasn't moving slowly or quickly. It wasn't becoming, it was timeless. And only when the observer looks does the particle not only snap into position, but also into a moment. The moment. Time begins with the act of observation. This links directly to the timeless quantum state, a formulation where the universe doesn't evolve in time at all. It just exists. The reason it appears to change is because we, embedded inside it, are comparing our observations across configurations. There's no ticking clock underneath. There's just information, unfolding when we check it. This also echoes the strange logic of photonic timelessness. Photons, which travel at the speed of light, don't experience time at all. From their perspective, their entire journey is instantaneous. It only looks like it took years from our slow, clock-bound point of view. So again, we ask, is time just a side effect of being slow enough to notice it? Some interpretations of quantum physics take it even further, suggesting that consciousness itself is required to bring about time. That the universe doesn't update its state until something inside it becomes aware. In this view, time isn't a river. It's a mirror. It reflects only when something looks into it. And that's what makes this paradox so disturbing. We like to think time is objective, cold, mechanical. But the more we study the quantum world, the more it seems that time isn't something we exist within. It might be something that exists only within us. REM Time Distortion. There's a strange thing that happens when you dream. You fall asleep. Maybe 20 minutes pass, but in that time you live through an entire storyline. You're at school again. You have a family. You've aged 30 years. Then just like that, you wake up. You check the clock. You've been asleep for 6 minutes. That's the paradox of REM Time Distortion. The idea that time inside your mind can run vastly faster than it does in the real world. Not a little, not metaphorically, but in measurable, functional terms. The explanation lies partly in how the brain stores sequences of thought. It's not like a video camera. Instead, it builds narrative frames, mental scenes, and stitches them together instantly. In REM sleep, these frames are triggered in rapid succession, unconstrained by the rules of external time. So your brain believes you've lived something real, because, in a very literal way it did, just faster than your clock can count. A closely related idea is the cognitive latency paradox, where your brain's awareness lags behind the moment things actually happen. When you wake from a dream, it doesn't feel like the dream ended. It feels like you were pulled out early, because you were. Your awareness caught up late, and by the time you understand what was happening, it's already gone. In some cases, this leads to dream loops. You keep having the same interaction over and over, waking up only to find that you're still dreaming, caught in a recursion. This blends into a similar phenomenon explored in the Chrono-Loop Perception paradox, the feeling that time is not just distorted, but repeating itself, especially within altered states of consciousness. Even more unsettling is when the dream feels longer than your real life. Some people report living decades, building families, careers, entire realities, only to wake and find those memories vanish in seconds. And yet, emotionally, they don't. You carry the grief of losing people who never existed. You feel nostalgic for lives that were never lived. Because to your brain, the emotional reality of that time was just as real as anything outside of it. And it doesn't stop with dreams. People in comas, hallucinations, or near-death experiences often describe warped or non-linear time, where the present fractures, memory dissolves, and every moment stretches, loops, or disappears. This distortion isn't a glitch. It's how the brain handles a world without input. When sensory signals vanish, your brain becomes the sole creator of time, and it doesn't follow rules. It simulates time as it needs to. In REM Time Distortion, you discover something terrifying, that your deepest experiences of time may be synthetic. That whole lives, whole stories, whole identities can be fabricated in less than a minute. And when you wake up, you're not just leaving a dream. You're escaping a lifetime that was never yours to begin with. Eternalism. Eternalism is the view that the past, present, and future all exist equally. You don't travel through time like moving along a line. Instead, your entire timeline, every moment you've ever lived or will live, exists all at once in a four-dimensional structure called space-time. This isn't a science fiction idea. It's a serious interpretation of modern physics, backed by the theory of special relativity. According to Einstein, simultaneity is not absolute. Two observers, moving at different velocities, may disagree on whether two events occurred at the same time. This is more than a thought experiment. It has been confirmed by experiments such as the Hafele-Keating experiment in 1971, where atomic clocks flown on airplanes experienced time at a different rate than those on the ground. This result, time dilation, means that now is relative. There is no universal present moment that suggests all moments past and future are equally real. They don't come and go, they just are. This view leads to the block universe model. In this model, the universe is like a solid block of space-time. Events are laid out across time the way cities are laid out across geography. Your birth, your death, and everything in between are all located within that block. From this perspective, time doesn't pass. You don't move through time. Instead, you exist at specific locations in the block, just like you exist at a physical location in space. This has major implications. First, the future already exists. That includes every decision you'll ever make, every action you'll ever take. They are all already in the block. So if eternalism is correct, free will is challenged, not because you don't make choices, but because those choices are already part of the structure. There is no changing the future. The future is already there. Second, the past is not gone. It may no longer be accessible to you, but it still exists in space-time. The moment your parents were born still exists. The moment you made your worst mistake still exists. You can't return to those points any more than you can teleport to a different place in space. But their reality is not erased just because you've moved beyond them. Eternalism is unsettling because it contradicts our lived experience. We feel like time moves. We remember the past, anticipate the future, and act in the present. But those are internal psychological processes. There is no objective now in physics. As physicist Carlo Rovelli puts it, the notion of the present has no meaning in physics. We experience time flowing, but the underlying structure of reality may not involve any flow at all. Eternalism also challenges how we think about death and impermanence. If all moments exist eternally, then no moment is ever truly lost. Loved ones who have died still exist in their time coordinates. You just aren't there anymore. But that also means your own death is already part of the block. It has already happened, just not from your current position in time. Finally, eternalism raises questions about moral responsibility. If all actions are fixed in space-time, then to what extent can people be blamed or praised for decisions? If someone's actions are determined by their position in the block, then choice may be a built-in part of the structure, not something spontaneously created. This doesn't mean morality disappears, but it may not be based on freedom. It may be based on consistency, predictability, or consequences inside the block. Eternalism is not universally accepted. Some reject it in favor of presentism or the growing block theory, both of which deny the equal reality of future events. But eternalism remains one of the strongest interpretations of spacetime according to modern physics. It doesn't feel intuitive, but intuition doesn't determine what's true. Observation and theory do, and eternalism has both. Let's go even further by looking at some of the variations of this paradox. One variation is the process versus object time distinction. This is a philosophical argument. Is time a process, unfolding second by second, or is it an object, a static structure we're just looking at from the inside? If it's a process, we can imagine the future as something that hasn't happened yet. If it's an object, then the future is already there, just inaccessible to us. In this model, the past didn't disappear, and the future doesn't arrive. They exist in parallel, like places on a map you haven't walked to yet. The ancient philosopher Heraclitus rejected this idea completely. He famously said, "You can't step into the same river twice." To Heraclitus, time was flux, constant, irreversible motion. He would have hated eternalism. To him, the essence of being was change. But in eternalism, the river never moved. You just looked at different frames of the river. There's another version of the paradox that takes the idea inward into the mind. It's called timeless consciousness. In some meditative or altered states, people report a loss of temporal perception. They stop experiencing moments as sequential. There's no before or after, just an overwhelming sense of now. To them, time isn't gone. It's just flat, eternal. It raises the question, what if our brains are built to trick us into believing in time flow, just so we can function? What if your experience of now is just a spotlight scanning across a still, silent structure? That brings us to the specious present, a psychological theory suggesting that even the present moment we feel isn't real. When you hear a melody, you're not hearing just one note. Your brain is buffering several seconds at once, then stitching them together. So even your now is already a miniature past. Even your consciousness has lag. So what happens when you put all of this together? Eternalism says, you didn't come from the past. You're not going into the future. You are a fixed point in a timeline that already exists. You are not moving. You are positioned. And here's the real paradox. If every moment already exists, then your sense of choice might be just as still. You feel like you're deciding things in the moment, but those decisions are already part of the map. It doesn't mean you're a robot. It means your freedom might be an illusion, built into the structure of time itself. So, eternalism isn't a theory of time travel. It's a theory of everything. Time as a cultural construct. The time as a cultural construct paradox explores the idea that while time may exist as a physical phenomenon, the way we experience it, and even define it, depends heavily on culture. This creates a contradiction. If time is objective and universal, why does it feel so different across human societies? We tend to think of time as fixed, seconds, minutes, hours, years, ticking by equally for everyone, everywhere. But across history and geography, people have experienced time in radically different ways. Start with calendars. The Gregorian calendar is the most widely used today, but it's just one system. The Islamic calendar is lunar and shorter by about 11 days per year. The Mayan calendar counted time in 260-day ritual cycles and 360-day tons. In Ethiopia, it's currently the 2010s, not the 2020s. Different cultures have different nows. Even the concept of time zones is artificial. It wasn't until the late 1800s, with the spread of trains, that standardized time zones became necessary. Before that, noon was simply when the sun was overhead, and every town had its own version of it. Now consider how cultures think about time. In Western societies, time is often treated as a line. You move forward into the future. You leave the past behind. You spend time. You waste time. You manage time. But in many indigenous cultures, time is cyclical. Among the Hopi people, the language doesn't separate past, present, and future the way English does. Time is about events and their readiness, not whether they have or will occur. In Eastern philosophy, like in Buddhism or Taoism, time may be seen less as a rigid path and more as a flowing field, something to harmonize with, not control. Even within one society, people relate to time differently. A factory worker on a shift clock, a monk in silent meditation, a child on summer vacation, and a patient in a hospital bed all live in the same world but experience time in completely different ways. And when you look at languages, this becomes even more clear. In Mandarin Chinese, time is often spoken about vertically, with the past above and the future below. In English, time flows left to right, the same way we read. But in Arabic and Hebrew, where writing goes right to left, people often visualize time moving in that direction too. This affects memory, imagination, even gesture. When people are asked to physically point to the future, their hand direction depends on their cultural context, even if their clocks are the same. So here's the paradox. Time, in the scientific sense, ticks uniformly everywhere. But our sense of it is shaped by the words we speak, the tools we use, and the worldviews we inherit. We all move through time, but we don't all live time the same way. And if your sense of now, later, and forever is built from language and culture, then how much of your time is truly yours, and how much was given to you before you could ever question it? Identity time loop. The identity time loop paradox asks a deceptively simple question: who are you, really, if your present self is shaped by who you think you'll become? We often think of identity as something that grows over time. You experience the past, you learn, you make choices, and those choices slowly shape the person you are. But psychology shows us that your current identity isn't just a product of the past. It's also constructed from your beliefs about the future. You don't just remember who you were, you predict who you're becoming, and then use that imagined version of yourself to decide how to act now. This creates a feedback loop. You make choices based on who you think you are, but your sense of who you are is based on the choices you expect yourself to make. It goes in a circle, your future self influencing your present self, and your present actions shaping the future self you expect to be. Here's a simple example. Imagine someone wants to be a doctor. They study, stay up late, sacrifice weekends, not because they are a doctor, but because they believe they will be. That future identity pulls them forward. But in acting like a future doctor now, they start becoming one. They build habits, confidence, and skills, all based on an identity that doesn't yet exist, but already defines them. Now rewind that feedback loop. Did they become a doctor because they were that type of person? Or did becoming that person start with pretending to be them? It's not just ambition. People recovering from trauma often report a moment where they imagined themselves healed, whole again. That image of future self became a kind of anchor even before the healing had happened. In that sense, your identity is not moving in a straight line. It's bouncing between memory and expectation, between who you remember being and who you hope or fear you're becoming. And this feedback loop is fragile. If you lose track of your imagined future self, your present choices can unravel. If you stop believing you're capable of change, the loop collapses. This shows up in therapy too. Cognitive behavioral approaches often rebuild identity by creating new narratives about the future. Instead of asking, "Who have you been?" they ask, "Who are you becoming?" And that imagined self becomes a tool for present transformation. But it also opens a deeper paradox. If your identity depends on who you believe you'll be, and that belief shapes who you become, then which version of you is the real one? Are you the person remembering, or the one predicting? Do you grow into your future, or loop endlessly through versions of yourself that only exist because you think they should? In that loop, identity stops being fixed. It becomes a recursive echo, a self that remembers forward and imagines backward. Reverse parenthood. The reverse parenthood paradox imagines a world where a child doesn't come from the parent, but the parent's identity comes from the child. At first, it sounds like wordplay, but the logic behind it exposes a deeper contradiction about time, memory, and meaning. Traditionally, we think of causality like this. Parent exists, parent gives birth. Child is born, child becomes who they are. Simple, linear, one-directional. But the reverse parenthood paradox challenges that flow. What if the child, by being born, by existing, by needing care, creates the role of the parent? What if being a mother, a father, or a caregiver doesn't really exist until the child defines it? You might biologically be a parent from the moment of conception, but psychologically, emotionally, and even socially, that identity is created through interaction with the child. Here's a real-world reflection. A man becomes a father. He's unsure, unprepared. He holds the baby, feeds it, loses sleep. Each gesture is unfamiliar at first, until slowly he becomes the person the child thinks he is. The child, by needing love, pulls the father into being. He wasn't fully a father until the child made him one. Not just genetically, but existentially. Now reverse that line even more. What if the future behavior of the child shapes how the parent remembers their own role? A child grows up, becomes successful, kind, wise. The parent says, "I raised them right." But if the child grows up angry, distant, broken, the same parent might say, "I failed them." In both cases, the parent's identity is retroactively rewritten by the future self of the child. Parenthood doesn't just create the child creates the parent. It's not just memory, it's meaning. The identity of mother or father is not fixed at birth. It grows, forward and backward, shaped by outcomes that haven't happened yet. This also happens in adoption. A person becomes a parent not because of genetics, but because of a decision and the bond formed afterward. It's the child's presence that creates the role, not the other way around. Or think about mentorship. A teacher only becomes a great teacher if the student becomes something great. Otherwise, they're just someone who once gave advice. So the paradox is not just about parenting, it's about identity formed after the fact, roles that only make sense in hindsight, causality that flows from future to past. If you can become something because of someone who didn't exist yet, and if your role is shaped by a future version of them, then you're not the origin of the story. You're the consequence. The child makes the parent. The listener makes the speaker. The future defines the past. Hidden witness paradox. Imagine you're in a room, watching someone make a choice. They can't see you. They don't know you're there. You're just present, silent, hidden. Their actions unfold exactly as they would have if you hadn't been there at all. Now ask yourself, did your observation matter? Did it change anything? Or were you just a ghost in time? This is the core of the hidden witness paradox, the feeling that you're part of a moment, but the moment would happen exactly the same without you. You're not interacting. You're not influencing. You're watching. But in that watching, you begin to question whether you were ever really there. This paradox becomes even more haunting when paired with its conceptual twin, the delayed observation paradox. This version comes not from psychology but from physics, especially quantum mechanics. In certain interpretations, a particle can exist in multiple states until it's measured. The act of observation is what causes the particle to choose a state, collapsing the wave of possibilities into a single outcome. But here's the twist. There are thought experiments where the decision to observe happens after the event has occurred, and yet still seems to determine the past. It's as if the universe is waiting to decide what happened until someone finally looks. Applied back to the hidden witness, the idea gets darker. What if something only becomes real once it's acknowledged? And what if the things you've seen, the memories you hold, don't exist in anyone else's timeline? What if you're the only witness to a version of reality no one else experienced? This shows up in everyday life in smaller, eerie ways. You recall a conversation that the other person insists never happened. You watch an accident unfold, but find no record, No reports, no confirmation, not even a scratch on the car. You were there. You saw it. And yet no one else did. So either your memory is lying, or the world forgot. Or worse, the moment was never meant to be observed. And then comes the psychological side. In trauma, dissociation, or extreme stress, people often report feeling like they're floating outside themselves, watching life happen from the corner of the room. Not participating, just witnessing. Like an invisible observer to their own timeline. Later they remember it all, but can't explain how they were there. It's memory without presence, experience without agency. In the hidden witness paradox, you become a silent camera inside time. You see the world unfold, but you're never sure if the world saw you back. And the longer you observe without being seen, the more you begin to ask, was I ever really here? Reverse entropy pocket. The reverse entropy pocket paradox asks, what if somewhere, even for a moment, time flows in the opposite direction? Not figuratively, literally. Where dishes unbreak, ashes reassemble into paper, and ice spontaneously forms in a glass of warm water. This is more than science fiction. It's a serious possibility raised by thermodynamics and cosmology. To understand it, we start with entropy, the measure of disorder. In any closed system, entropy increases over time. That's the second law of thermodynamics. Things fall apart. Order decays. Eggs don't uncrack. This law is so deeply embedded in our world that we use it to define the arrow of time. You know time is moving forward because coffee cools, not warms. Because memories form, not erase. Because people grow older, not younger. But here's the paradox. The laws of physics at their core don't care about direction. The equations work just as well forward or backward. If you filmed a planet orbiting a star and played it in reverse, Newtonian physics wouldn't notice. There's no rule that says the past has to precede the future, except entropy. Now imagine this. Somewhere, somehow, a region of the universe exists where entropy decreases instead of increasing. A bubble of time that flows backward. To us it would look like miracles. Smoke flows into a cigarette. People grow younger. Raindrops leap from puddles back into clouds. It wouldn't feel wrong to the people inside it. Because for them, entropy decreasing is the forward direction. Their memories would be organized from high entropy to low, in reverse to us, but normal to them. This creates the reverse entropy pocket paradox. If time's direction is defined by entropy, then time might flow differently in different parts of the universe. And you might not know you're in one, because your memories and your logic would adjust with it. Some cosmologists have taken this seriously. In certain models of the early universe, it's possible that after the Big Bang, two universes expanded in opposite temporal directions, each believing they're going forward in time, while appearing reverse to each other. Imagine meeting someone from the other side. They'd seem bizarre, walking backward, speaking in reverse, undoing actions you just witnessed. But from their perspective, you are the one going backward. Neither of you would be lying. You'd just be entangled in opposite time arrows. This flips everything we know about cause and effect. What if some rare phenomena we observe, quantum anomalies, spontaneous organization, memory glitches, are actually signs of encountering a reverse entropy event? What if déjà vu is a perceptual crack between opposing directions of time? The paradox cuts deep. If time is driven by entropy, and entropy can run backward under the right conditions, then time itself might be reversible, not everywhere, but somewhere. And if that pocket ever touched our world, we might not recognize it until it's already undone us. Temporal collapse warfare. Temporal collapse warfare is the hypothetical paradox where time itself is destabilized, not by accident but by design. A conflict not fought with bullets or bombs, but by shattering the timeline your enemy depends on to survive, think, or even exist. At its core, this is a weaponization of time distortion. If you can't destroy your enemy's body, you destroy their ability to live in a coherent cause and effect world. The idea sounds like science fiction, but it has terrifying roots in real physics and psychological warfare. Start with the battlefield of the mind. A human brain requires temporal consistency to function. We rely on the past to predict the future. Memories shape identity. Anticipation drives decision-making. If you want to break someone, truly break them, you don't need to torture their body. You just need to collapse their timeline. Now imagine a weapon that does exactly that. Not by speeding up time. Not by rewinding it, but by flooding your enemy with too many timelines at once. They receive information out of sequence. A command arrives before the plan it refers to. A memory appears of something that hasn't happened yet. Their perception of now begins to slip. They no longer know what's real, what's coming, what just happened. This is temporal warfare, where you induce psychological collapse by removing temporal order, like pulling the ground out from under someone's sense of self, but take it further, to the level of physical systems. Modern defense infrastructure runs on timing precision. Missile defense, satellite targeting, encrypted communication, all rely on synchronized clocks. A nanosecond of drift can cause failure. A temporal disruption, targeted carefully, could blind a network, disable a shield, or crash a currency. A well-placed time lag introduced into a communication chain can cause two units to attack each other. A GPS system disrupted by relativistic interference, say by a rotating gravity well or even a weaponized gravity anomaly, could send entire fleets off course. It's not hypothetical. In general relativity, we know that gravitational time dilation is real. Time moves slower near strong gravitational fields. This effect already affects satellites and must be corrected for GPS to work at all. Now imagine if that principle were turned into a weapon. A satellite that subtly warps local time by microseconds and random pulses. Not enough to detect immediately, but enough to desynchronize a defense system just as an attack begins. That's temporal collapse warfare. Not loud, not fiery, but system-wide confusion, based on time no longer flowing reliably. But it doesn't stop with tech. Think about information warfare. In a digital society, people believe what they see now. But what happens when now becomes unstable? You see a headline dated yesterday, but it was posted an hour ago. A video appears to be live, but it's already been edited. Chatbots inject information labeled as archived, but it hasn't happened yet. The truth collapses when timing collapses. People start to doubt what came first. They forget whether they made the decision or were manipulated into it. And as their sense of temporal order unravels, so does their ability to resist. That's the darkest edge of this paradox. You don't destroy your opponent's world. You make them unsure when it exists. You replace their battlefield with a storm of causality errors, fractured memory, and emotional detachment. And soon they're not fighting you anymore. They're trying to remember who they are, in a timeline that doesn't line up with their mind. Chrono-Dissonance Collapse. The Chrono-Dissonance Collapse paradox occurs when a single person or an entire system begins to experience multiple conflicting timelines at once, and the sense of reality begins to fracture. It's not time travel. It's not memory loss. It's the feeling that you're living in one moment and in several others simultaneously, none of which agree. At its core, it's a paradox of perceptual time versus physical time. Your body says it's now. Your thoughts are in the past. Your anxiety is in the future, and your environment, with digital notifications, algorithmic feeds, archived photos, and global timelines, starts feeding you all of them at once. This isn't just theoretical. Let's start with something everyone can relate to. You wake up and your phone immediately shows you a memory from 6 years ago. You smile until you remember who you were back then, who you were with, what you had, and what you've lost. You're lying in 2025, but for a second, you're emotionally in 2019. Then your work calendar flashes a meeting. Your brain jumps to 10 hours a.m. Then a breaking news alert pulls you into someone else's tragedy, happening right now in a different time zone. And then a video autoplay suggests something you watched last week. In less than 30 seconds, your mind has been split across 5 different timelines. It's disorienting, but it happens all the time. In psychology, this dissonance is called temporal fragmentation. When people lose their ability to locate themselves in a stable time frame, it's common in PTSD, in dissociative disorders, in burnout. It's when your body's in the present, but your awareness is stuck in a memory loop or preparing for a catastrophe that hasn't happened yet. But the paradox becomes deeper when it spreads across people. We used to live by shared clocks, the sun, the seasons, local time. Now, a single event, a tweet, a video, a political moment echoes across the planet on radically different timelines. One person reacts instantly, another sees it a week later, a third reinterprets it a year after the fact, and it all feels current to them. This is chrono-dissonance. One event, multiple timelines, no agreement on what it means or when it really happened. It affects history too. A protest happens. Live coverage tells one story, security footage another. Eyewitness memory reshapes the narrative again days later, and years later, the documentary reframes it completely. Which version is the real one? Which time holds the truth? When you live long enough in a world like this, something begins to break. You start to doubt your own memories. You start to mistrust your sense of time. You hear a song and can't tell if it came out 2 years ago or 20. You reread an email and wonder if it was written before or after the event you thought it referenced. You start to feel like time isn't linear, not because you're philosophizing, but because your experience no longer supports the idea that it is. Now stretch this paradox to the limit. Imagine a future where memories are implanted, realities are simulated, news cycles are fragmented by AI, and everyone carries their own personalized version of time, curated by algorithms. Each person walking in their own private timeline, glitching against each other. Truth collapses not because people lie, but because no one is experiencing the same one anymore. And when time becomes too fractured to agree on, reality itself begins to collapse. Not physically, but psychologically, culturally, emotionally. This is the Chrono-Dissonance Collapse, a slow, untraceable unraveling, caused by time refusing to stay in one piece. Polchinski's Paradox. Polchinski's paradox is one of the clearest and most disturbing causality paradoxes ever proposed in physics. It doesn't rely on people or prophecy. Just a ball, a wormhole, and the question, what happens if a time traveler destroys their own reason for traveling? Physicist Joseph Polchinski introduced this thought experiment in the 1990s to test how time travel would behave under the rules of known physics, specifically general relativity, which allows for closed time-like curves, a mathematical version of a time loop. Here's the setup. Imagine a perfectly smooth billiard table. On the table sits a wormhole, a tunnel through space-time, with one end set just a few seconds in the past. You roll a billiard ball toward the wormhole. It enters, and a moment later, it emerges from the other end, just before it entered. Now imagine that when it comes out, it hits its earlier self just enough to knock the original ball off course. It never enters the wormhole, which raises the question, if the ball never entered the wormhole, how did the future version come out to stop it? This is a causal loop with no consistent resolution. It's not just confusing, it's logically impossible. If the event happens, it prevents itself from happening. If it doesn't happen, then there's no reason it couldn't happen. This isn't a story about people or machines. It's pure physics, a paradox that appears even when emotion and motivation are stripped away. Just a ball, just motion, just logic. So what happens? Some physicists like Kip Thorne and colleagues took this very seriously. They analyzed whether it was physically possible to resolve the paradox by finding a self-consistent trajectory, a way the ball could come out of the wormhole and still nudge its past self, but not enough to stop it from entering. And in some versions, this works. Instead of stopping itself completely, the ball gives its younger self a slight deflection, sending it into the wormhole at a slightly different angle, which causes the same slight deflection in a closed loop. In this case, the loop is stable and self-consistent. Every action causes itself in a neat, infinite spiral. But Polchinski's original question still haunts the model. What if no such stable loop exists? What if the collision always creates a contradiction? Then we're left with a universe where some initial conditions cannot exist because they would lead to a time paradox. And this brings up a deeper issue. Does the universe somehow forbid paradoxical setups? Do the laws of physics conspire, not just to govern matter and energy, but to protect causality? This leads to the Novikov Self-Consistency principle, which proposes that any event that could cause a paradox simply has zero probability of happening. In other words, time won't let you break it. But that raises even more disturbing questions. If certain outcomes are not allowed, then is your free will just a mirage, a carefully fenced path through time's logic gate? And if something as simple as a billiard ball can collapse the timeline, how would a human survive one? Every intention, every choice, every reason you think you're acting, could be tangled in a web of timelines that you're not allowed to unravel. Schrödinger's time traveler paradox. You've heard of Schrödinger's cat, the thought experiment where a cat in a box is both alive and dead until you look. A paradox of quantum superposition. A way of showing how reality can exist in two states at once until observation collapses it. Now take that logic and apply it to something far more disturbing. A time traveler. Someone who might have arrived from the future, or might not. Someone whose very existence depends on whether we choose to look for evidence. This is the Schrödinger's time traveler paradox. A person whose presence in the timeline is in a state of quantum uncertainty, both present and not, until history is examined. The setup. Imagine this. A historian in the year 2475 discovers a journal hidden in the ruins of an old observatory. It describes events, names, and personal interactions in stunning detail, too detailed for any known archives. The author claims to be a time traveler from the year sent back to the 21st century to observe, not interfere, but the journal ends abruptly. The final page reads, "If you're reading this, I was never meant to be found." The historian shares it. The world speculates. Some say it's a hoax. Others say it proves the existence of time travel. But then a deeper analysis reveals inconsistencies. The events described begin to shift. Facts that were once true begin to change. The journal itself begins to blur. Details rewriting themselves. Now here's the paradox. If the time traveler was never meant to be discovered, then their presence in the past should be erased. But by discovering the record, by observing it, the historian has collapsed the timeline into one where the traveler was real. Unless, of course, they weren't. The time traveler exists in a kind of quantum state. If no one knows they arrived, then they never did. If someone finds proof, then the proof becomes the reason they existed. It's the same logic as Schrödinger's cat, uncertainty until observation. But now the box is time itself. In this paradox, observation isn't just passive, it creates the reality. By trying to prove the time traveler existed, you cause them to exist. And by questioning that existence, you risk erasing them from memory. In some interpretations of quantum mechanics, particularly the many worlds interpretation, every possible outcome exists in its own universe. So maybe there's a universe where the time traveler landed safely, one where they were discovered, one where they were not, and one where they were both, flickering between timelines, caught in a loop of possibility. Now imagine being that traveler. You don't know if you've been erased. You don't know if you were ever really here. You leave messages behind, not to warn, not to change, but just to collapse the waveform. Because until someone finds your trace, you are in a superposition of timelines, a ghost that may or may not have stepped into history. That's all the strange time paradoxes we've explored so far. Now let's shift gears and relax a little with some of the most famous and mysterious time-related stories in history. Some are well documented, some are controversial, and some might just be too weird to ignore. The man from Taured. In the summer of 1954, a man stepped off a plane at Tokyo's Haneda Airport. Well-dressed, calm, businesslike. At first, nothing seemed unusual. He handed his passport to the customs officer like everyone else. But when the officer flipped it open, he hesitated. Because the passport, official in every way, was from a country that did not exist. Taured. The man didn't understand the confusion. He spoke fluent French, Japanese, and several other languages. He claimed this was his third business trip to Japan that year. He showed stamps in his passport from previous visits. He carried currency from multiple European countries. His checkbook was issued by a well-known international bank. When asked where Taured was located, he pointed confidently at a map. His finger landed on the border between France and Spain, where the microstate of Andorra sits today. But when he didn't see the word Taured, he grew visibly frustrated. He insisted his homeland had existed there for over 1,000 years. By this point, immigration officials had moved him to a secure interview room. They ran his name. No matches. They called the company he said he was visiting. It had no record of him. They contacted the hotel where he said he had a reservation. They had never heard of him. Even the business associates he claimed to meet that afternoon did not exist. His documents were taken for inspection. They looked authentic. Not forged. Not cheaply made. Real paper. Real watermarks. Even the visa stamps appeared to be issued by Japanese authorities, but none matched any template in their system. At first, officials suspected espionage. 1954 was a tense time globally. The Cold War, territorial disputes, intelligence agencies everywhere, but the man didn't fit the profile of a spy. He didn't resist. He didn't seem trained to mislead. He was cooperative, polite, and genuinely confused. They ordered him held overnight in a business hotel near the airport. 2 immigration agents were assigned to watch the hallway. They placed him in a room with no balcony. 10 floors up, the windows were sealed shut. His documents, passport, currency, checkbook, and a briefcase were secured in a locked drawer at the immigration office. And in the morning, he was gone. The bed hadn't been slept in. The bathroom was dry. No footprints, no signs of forced entry, no exit on the camera, and most disturbing of all, his documents were gone too. The immigration drawer had not been tampered with. No fingerprints, no broken lock. The surveillance cameras in the hallway showed nothing, not even the guards moving. It was as if the man had never arrived. Tokyo police launched an internal investigation. The hotel was shut down for a week. Airport staff were interviewed. Flights in and out of Haneda were re-examined. Nothing turned up. The man from Taured, whoever he was, had vanished without a trace. Not escaped. Not fled. Vanished. The case was never closed. It was never publicly admitted either. Over time, the file was quietly archived, somewhere inside Japan's Ministry of Justice. Some claim it was a mental breakdown. A man with forged documents and a delusional identity. Others whisper of diplomatic cover-ups, experimentation, or the early days of something darker, something never meant to be seen. But there are a few, those who study what they call anomalous presence, who believe he wasn't a spy, or a fraud, or a liar. They believe he was real, just not real here. A traveler from a parallel dimension, or a fracture in the timeline. A glitch in the matrix of history that appeared for one moment and was corrected by the system just as quickly. Because if his country never existed, then neither should he. John Titor. In November 2000, a user calling himself John Titor began posting on an online forum for time travel discussions. His message was simple. I am from the year 2036. I am a soldier sent back in time to retrieve an IBM 510-100 computer from the year 1975. He claimed to be part of a military unit based in Tampa, Florida, and said he was on a stopover in the year 2000 while traveling from 2036 to 1975, a path he claimed was necessary due to time machine limitations. Titor described his time machine in detail. He called it a C-24 gravity distortion unit built by General Electric and said it used 2 miniature rotating Kerr black holes suspended in a magnetic field. He even uploaded diagrams describing how it could manipulate gravity to distort time, mounted inside a 1967 Chevrolet. His tone was technical, not dramatic. He answered questions from forum users for months. When asked why he needed the IBM 510-100, he said it had a hidden feature that allowed it to emulate older computing languages, which would be necessary in his time to debug legacy code. Sabat's feature was not public knowledge in 2000, but was later confirmed by engineers who had worked on the machine in the 1970s. He claimed his timeline had diverged slightly from ours, which meant events might unfold differently here. But he still offered predictions that the U.S. would enter civil conflict beginning in 2004, with full-scale civil war erupting by 2008. That a brief but devastating World War III would occur in 2015, involving nuclear strikes that would kill millions. That after the war, society would reorganize into smaller decentralized communities. That the United States would split into 5 regions, each with distinct systems and military presence. That Russia would be the primary aggressor in the war. That CERN would discover the basis for time travel through miniature black holes in the early 2000s. When users asked for photographs, Titor posted several, including grainy images of what he claimed was his time machine's internal system and user interface. He discussed future technologies, social collapse, global distrust in centralized power, and the growing importance of family, community, and self-reliance. He spoke in a way that felt coherent, consistent across hundreds of posts. By March 2001, John Titor announced he would be returning to 2036. He stopped posting. The account went silent. He was never heard from again. Afterward, the internet erupted with analysis. Some focused on his predictions, most of which did not come true, at least not in the way he described. Others focused on what he got right, or at least what he shouldn't have known. The IBM 510-100's hidden functionality was real, confirmed by engineers after Titor's disappearance. CERN did begin advanced experiments with mini black holes, as he suggested. His explanation of multiverse-based time travel matched later popular quantum interpretations of alternate timelines. Investigators traced the post to a user likely based in Florida, possibly connected to a man named Larry Haber, an entertainment lawyer, and his brother, a computer scientist. But nothing was ever confirmed. No solid link, no confession. Over time, another theory began to take hold. That John Titor was not real, but also not just a hoax. That he was a test, a seeded narrative meant to study how people respond to the idea of time travel. A social engineering experiment, a long-form psychological test, a disinformation model, or worse, an intentional leak, hidden in absurdity so that no one would take it seriously, so that if time travel were ever revealed, we'd already be conditioned to dismiss it. Whether he was a hoax, a warning, or something else, the name John Titor remains one of the internet's most enduring unsolved stories. Andrew Carlssin. In early 2003, a story began circulating through Yahoo News and several fringe publications. It claimed that a man named Andrew Carlssin, age 44, had been arrested by the U.S. Securities and Exchange Commission after turning $800 into $350 million in just 2 weeks through a series of nearly impossible stock trades. According to the reports, Carlssin made 126 consecutive high-risk trades, all of which paid off. No losses, no uncertainty. Each investment was timed perfectly around market fluctuations no one else saw coming. The SEC flagged the activity as suspicious. He was detained and questioned. And then the story gets strange. During his interrogation, Carlssin didn't deny wrongdoing. He didn't ask for a lawyer. Instead, he gave a confession that stunned the agents in the room. He claimed to be a time traveler from the year 2256. He said he had used knowledge of future market trends to build up the funds for a rescue operation. He claimed he had traveled back in time to correct a timeline anomaly, though he never explained what that anomaly was. He also claimed he had information about the cure for AIDS, the location of Osama bin Laden, and the precise date of the U.S. invasion of Iraq. According to some sources, he offered to provide these details in exchange for leniency or for permission to return to his timeline. At first glance, this sounds like satire, but then came the confusion. No record of Carlssin's existence could be found before December 2002. No birth certificate, no driver's license, no tax history. Nothing. Even the FBI, reportedly brought in to investigate, was said to be frustrated. He had no digital footprint, no trail of identity that predated his sudden appearance as a financial savant. Then, after being held in federal custody for a brief period, he vanished. Reports claim he was granted bail by an anonymous third party. After that, he failed to appear for his court date. Attempts to track him down failed. He was never seen again. Now this is where the line between fact and fiction begins to blur. Some say the story originated from Weekly World News, a tabloid known for outrageous headlines. However, what makes Carlssin's case stand out is that it was reposted by Yahoo News, quoted by legitimate financial sites, and discussed in forums where users tried to trace the legal filings and found nothing. No case number, no docket, no arrest record, only second-hand reports, all referencing each other. Circular sourcing, no origin, which leads to two theories. 1. The story was fake from the start, a media stunt or copy-paste hoax that gained traction in the early internet age, when news moved faster than fact-checking. 2. The story was real and deliberately buried. The CIA and SEC never commented. The FBI never issued a statement. There was no official denial, only silence. Some conspiracy theorists believe Carlssin wasn't alone, that he may have been part of a broader operation, a real experiment involving time manipulation and financial disruption, that his arrest was not supposed to be public and the story was leaked too early, possibly by someone on the inside. They point to the timing late 2002, right before the Iraq War, right before massive economic shifts, right before the data age exploded. Carlssin didn't try to change the world. He didn't invent anything. He didn't make speeches or post predictions online. He made money, silently, consistently, then disappeared. Whether it was a hoax, a buried investigation, or something else entirely, the mystery of Andrew Carlssin remains unsolved. And if he really was from the future, maybe we just weren't supposed to catch him. The Chronovisor. In 1972, an Italian priest named Father François Brune published a book titled The Vatican's New Mystery. In it, he described a conversation he'd had years earlier with another priest, one who made a chilling claim. The man's name was Father Pellegrino Ernetti. He was a Benedictine monk, a scholar, and a respected physicist. And he said that deep inside the Vatican, hidden from the world, there existed a device capable of viewing the past. Not metaphorically, not symbolically, literally. A machine that could show you events that had already happened as they unfolded. It was called the Chronovisor. According to Ernetti, the Chronovisor worked by detecting and reconstructing residual electromagnetic radiation left behind by past events. He claimed that every action, every sound, every image that had ever occurred left behind an echo, imprinted on the fabric of space-time, and that these echoes could be seen again if you had the right technology. He described the machine as a kind of screen, a curved cathode ray display, connected to antenna-like sensors, and a complex array of tubes and coils. He said it could tune into specific moments from history, not just in one location, but anywhere on Earth. And according to Ernetti, the Vatican used it. He claimed to have seen the crucifixion of Jesus Christ, a lost tragedy by the Roman playwright Quintus Ennius, the speeches of Cicero, the founding of Rome itself. Ernetti said the Chronovisor was built in the 1950s with help from a secret team of scientists, including Enrico Fermi, one of the fathers of the atomic bomb, and Wernher von Braun, the Nazi rocket engineer later recruited by NASA. The machine, he said, was so powerful and so dangerous that it was eventually dismantled and hidden away. He claimed the Vatican feared it could be used to alter political history, falsify evidence, or expose sacred truths. Too many people, he said, would want to use it for the wrong reasons. In the years that followed, the Vatican never confirmed or denied the machine's existence. When asked directly, church officials dismissed the story but offered no concrete rebuttal. Then came the photo. In the early 1980s, a grainy image surfaced, allegedly captured from the Chronovisor itself. It showed the crucified Christ, eyes turned upward in agony. It circulated among Catholic groups and alternative history circles. But then another photo surfaced, nearly identical, published in a 19th-century postcard of a wood sculpture in an Italian church. Many dismissed the Chronovisor as a hoax. Ernetti died in 1994. Shortly before his death, he allegedly signed a confession, claiming the Chronovisor was a fabrication. But friends close to him said the confession was coerced, that he died still insisting it was real. And here's where it gets strange. In 2002, the Vatican issued an unprompted warning to all clergy and researchers. The statement, buried in a broader theological bulletin, read, "Any person using an instrument of such characteristics would be excommunicated." No further explanation. No mention of time machines. Just excommunication for using a device that, according to official doctrine, does not exist. Since then, no new photos, no scientific papers, no whistleblowers, just silence. And yet the idea persists that somewhere beneath the Vatican, buried in stone behind sealed doors, lies a device that can see any point in history as clearly as if you were there. A machine that doesn't just observe time, it violates it. And if the Chronovisor was real, maybe it wasn't dismantled, maybe it was locked away, waiting for a future the Church fears even more than the past. The Time-Traveling Hipster. In 2010, the Browlern Pioneer Museum in British Columbia, Canada, digitized an old photograph from the opening of the South Fork Bridge, taken in the early 1940s. It looked like any black and white image from the time. Men in hats, women in coats, an event, a crowd, nothing unusual, except for one man. In the center left of the photo, slightly detached from the others, stands a figure that doesn't fit. He's wearing sunglasses, modern ones. His hair is unkempt, not slicked like the men around him. He's wearing what appears to be a screen-printed t-shirt under a zippered cardigan, something completely out of place in 1940. His camera, hanging from his neck, looks decades ahead of its time. People online quickly dubbed him the Time-Traveling Hipster. The image went viral. Reddit threads exploded. Analysis videos appeared on YouTube. Some called it the clearest photographic proof of time travel ever captured. Skeptics began investigating. They searched vintage clothing archives and found similar sunglasses used by some athletes in the 1930s, but not commonly worn. They found early examples of portable cameras that could vaguely resemble the one he's holding, but still off in form factor. As for the shirt, no match. No product. No logo. No record of any kind of screen printing like that from the 1940s. It wasn't just his outfit, it was his posture, his demeanor, his expression. He looked casual, out of sync with the others around him. Not like a man attending a bridge opening. More like someone watching a moment in history play out, detached, relaxed, unbothered. Like he already knew what would happen. And then came the inconsistencies in the image itself. Some noticed that the light levels on his clothes didn't match the brightness on those around him. His focus was sharper, his contrast slightly higher. Was it an early Photoshop job? Experts examined the negative. It checked out. There was no evidence of tampering. The photograph was real. So the questions only got louder. Was he a time traveler? Was it a clever hoax, planted decades earlier? Was he just a man ahead of fashion trends? Or was this something else entirely? Theories flooded in. Some said he was part of a classified experiment, a subject accidentally caught in a historical photo during a government time travel trial. Others believed it was a momentary timeline bleed, a person slipping through briefly and caught in film before returning. A few believed it was intentional, a message, a breadcrumb, not proof, but a hint. Like someone wanted us to notice, to ask the question. Because the real mystery isn't just how he got there, it's why he was there, watching. And if one traveler could slip into a photo that made it into a public museum archive, how many more have slipped into the background, unnoticed? How many photos have we seen, crowds, protests, ceremonies, without ever looking at the faces too closely? The Versailles time slip, In August 1901, two English academics, Charlotte Ann Moberly and Eleanor Jourdain, took a trip to Versailles, the former royal palace just outside Paris. Both women were scholars. Moberly was the principal of St. Hugh's College, Oxford. Jourdain was her assistant, educated, rational, and not prone to superstition. They had no idea they were about to walk into one of the strangest and most controversial time anomalies ever recorded. It began with a casual visit to the Petit Trianon, a small chateau on the palace grounds, once the private retreat of Marie Antoinette. But as they strolled the gardens, something felt wrong. The air grew heavy, the landscape still and quiet. There were no birds, no wind, a silence that felt unnatural. Then they saw people, but not tourists. Men in green coats with tricorn hats, women in 18th century dresses. A man sat by a garden structure, his face pockmarked and unsettling. He looked directly at them, his stare described later as full of hatred. Jourdain asked one of the men for directions. He waved vaguely, spoke in a strange accent, and moved on. Soon the women reached a terrace, where they saw a young woman sketching. She wore an old-fashioned gown, and her hair was styled high. She didn't look up. Later, both women became convinced they had seen Marie Antoinette herself, moments before the French Revolution. Then, just as suddenly, everything returned to normal. The air lifted. Tourists appeared. The buildings looked modern again. And the people were gone. They left Versailles shaken, but they told no one. Not at first. Over the following weeks, they compared memories, drew maps, and began researching the layout of the gardens as they had been in the late 1700s. To their shock, they discovered that several of the paths they walked no longer existed in 1901, but did match the palace's older maps. The sketching terrace had also changed since Marie Antoinette's time, yet they had described it exactly as it looked in 1789. In 1911, under pseudonyms, they published a book, An Adventure. It caused a sensation. Some dismissed it as imagination, suggestion, or hallucination. Others pointed out how closely their recollections matched historical details they shouldn't have known. Critics said the women were likely influenced by nostalgia or subtle psychological suggestion from the environment. But defenders noted how consistent and unemotional their writing was. Not dramatic, not spiritual, just clinical. Their story never changed. And they never profited from it. Years later, when their identities were revealed, both women stood by every word. They remained adamant until their deaths. They had walked into the past. Today, the Moberly, Jourdain incident is considered one of the most credible time-slip stories in history. Not because it's provable, but because it was recorded so early, in such detail by two highly rational people. And the question remains, what did they experience? A hallucination shared by two minds. A crack in time itself. A haunting replay of historical energy. Or something else. Something we still don't understand. Because if time doesn't always flow, maybe in the right place, under the right conditions, it folds. Rudolph Fentz. The story begins in New York City. In the summer of 1950, just before midnight, a man was spotted standing in the middle of Times Square, confused and disoriented. He wore a long black coat, buttoned high, a silk top hat, tight pants, facial hair curled into neat Victorian styles. Witnesses said he looked lost, like someone had dropped him into the wrong century. Seconds later, he darted into the street and was struck by a car. He died instantly. At first it looked like just another tragic accident, until police checked his belongings. Inside his pockets, they found a copper token for a beer from a saloon no one had heard of, a bill for the care of a horse and the washing of a carriage, a letter dated June 1876, business cards with the name Rudolph Fentz, an address on Fifth Avenue, and around $70 in mint-condition 19th century currency. None of the items showed signs of age. The ink wasn't faded. The clothes, though old-fashioned, were unworn. They ran his fingerprints. Nothing. They contacted the address on the business card. The current residents had never heard of him. So the police dug deeper. Eventually, they found a Rudolph Fentz Jr. listed in a 1939 phone book. They reached out, only to learn he had died 5 years earlier. But according to public records, his father, also named Rudolph Fentz, had disappeared in 1870. He had gone for an evening walk and never returned. No body, no suspect, just gone. Now nearly 75 years later, a man matching that name, age, and description reappeared, only to die minutes later in a time he couldn't understand. The file was quietly closed. There was no next of kin, no one claimed the body, and no official explanation was ever issued. For decades, the story of Rudolph Fentz lived in fringe newspapers, paranormal digests, and time travel conspiracy books. Some argued he'd slipped through a time portal, a one-way fracture in the timeline that swallowed him from 1876 and dropped him into 1950. Others claimed it was a fabricated tale, written in the 1970s by a sci-fi author and confused over time as real. Then a researcher tracked the origin of the story to a 1951 science fiction magazine in a short story titled I'm Scared by Jack Finney, the same author who later wrote The Time Traveler's Wife. So it was fiction, right? Maybe. But then came a twist. The short story wasn't published until months after reports of the Fentz incident were already circulating. Some claimed Finney was inspired by the case. Others believed he had fictionalized a real suppressed police file. To this day, no original police reports have been verified. No newspaper archives show coverage from 1950. But the story refuses to die. It keeps resurfacing. Books cite it. YouTube videos dissect it. Forums dig for records that never existed or were never meant to, because if it was real, then somewhere in New York, for one night in 1950, time tore open and one man fell through. The forest where time runs wrong. There's a stretch of forest in the northern United States that locals refuse to name. Some call it Dead Loop Hollow. Others just say, don't go past the third marker. No official maps mark anything strange, but everyone who lives nearby knows something's off. It's not a haunted forest. There are no ghost stories, no old legends, no blood-soaked history, just missing time. It starts small. Watches stop, phones glitch, GPS units lose signal, then reconnect with timestamps hours behind. And then the real problems begin. One hiker, a 29-year-old man training for a mountain trek, entered the area early one morning. He'd mapped out his route, left a GPS tracker on, and told his friend he'd be back in 4 hours. He returned 2 days later. His clothes were clean, no signs of injury. His water bottles were full. But his friend said he'd already called the police. They were about to start a search. The hiker was confused, genuinely. He said the trip took maybe 3 hours. He remembered the sun moving across the sky like normal. He remembered taking breaks, checking his compass, but when they downloaded his GPS tracker, it showed something else. There were gaps, long stretches where no movement was recorded, as if the device had been paused. Then bursts of speed, almost impossible movement, like someone had carried the tracker through the woods at 60 miles per hour for no reason. Then, stillness again. Other stories followed. A couple camping in the area claimed they fell asleep around 11 p.m. They woke up the next day at 4 p.m., not morning. They hadn't overslept. They hadn't moved. Their fire was cold. Their food was untouched. But both of their watches and their phones read 4:03 p.m. exactly. Their tent was covered in dew, as if it had been there for days. And their photos, time-stamped automatically, had nothing between 11:02 p.m. and 3:59 p.m. Locals who grew up near the forest talk about the spiral trees, a stretch where the trunks don't grow straight, but twist like something is pulling them sideways, very slowly for decades. They talk about animals that avoid the area. No birds, no deer, no nests, silence. A few years ago, a government survey team came to measure magnetic anomalies in the region. They packed up after 3 days. No public report was filed. But one technician, later interviewed anonymously, said their compasses spun randomly within the center of the area, even the digital ones. He described the air as stiff, as if you were walking through a pressure change, but with no wind, no weather, and no altitude difference. So what's happening in Deadloop Hollow? Some think it's just electromagnetic interference, a mineral formation underground, maybe magnetite, throwing off instruments. Others suggest a localized gravitational anomaly, a natural warp, something like a Lagrange point on Earth's surface. And then there are the darker theories. A field experiment gone wrong, a leftover artifact from a Cold War project, a spatial scar, a tear in the consistency of time, left over from something that doesn't belong here. But the scariest part isn't the silence. It isn't the missing time. It's how consistent the people are when they come back. They're not hysterical. They're not rambling about portals or aliens or ghosts. They're calm, focused, certain that they were only gone a few hours. The clocks say otherwise, but they never feel it. Which raises the question, what if time isn't slipping, but we are? The Montauk Project. It started with rumors. A decommissioned Air Force base in Montauk, New York. Closed, fenced off, heavily guarded. Locals said strange things had always happened there. Electrical storms without weather, machines humming underground, children going missing. But the rumors didn't take shape until Preston Nichols, a former defense contractor, claimed he worked on something far beyond radar. He said Montauk was home to a secret government experiment. A continuation of the Philadelphia experiment, which allegedly made a Navy ship disappear in 1943 and accidentally ripped a hole in space-time. According to Nichols, that technology wasn't abandoned, it was moved to Camp Hero, beneath Montauk Point, and what followed was called the Montauk Project. Nichols claimed it began in the 1970s as an extension of psychological warfare research, mind control, remote viewing, and telepathic suggestion. But eventually, it evolved into something else: time manipulation. The story goes that scientists working underground at Montauk began experimenting with electromagnetic fields and scalar technology, attempting to induce artificial portals. They allegedly used a massive transmitter, the SAGE radar array, to pulse frequencies directly into the brain. They claimed they could implant thoughts, create hallucinations, even control moods on a regional scale. But the real breakthrough came in 1983. That's when Nichols said they made contact, not with other beings but with other timelines. They created a temporal tunnel, a corridor, he said, that allowed them to view or access other time periods. At first it was visual, a screen that showed the past, then it became physical. He claimed subjects were sent through, humans. Some returned, some didn't. And then came the children. Multiple witnesses who later came forward, including Al Bielek, who also claimed involvement in the Philadelphia experiment, said the Montauk team recruited runaways, orphans, and undocumented minors for experiments. They called them the Montauk Boys. They were allegedly trained in telepathy, subjected to trauma-based programming, and used in tests involving dimensional travel. One of the most disturbing claims, that time loops began forming, that certain subjects returned before they left, that some aged rapidly while others never aged again. Nichols even described an event where a subject, a boy with powerful psychic ability, manifested a creature from pure thought. A beast that tore through the base. He said it was so powerful they had to shut the entire project down. They destroyed the equipment, buried the data, erased the operation. The government, of course, denies everything. The base remains closed, fenced off, and officially empty. But the SAGE radar still stands. No other facility has one like it. And for some reason, it's still maintained. No one can explain why a Cold War radar site would need routine maintenance, decades after it was decommissioned. Skeptics say it's all delusion, an elaborate hoax fueled by science fiction and Cold War paranoia. But others point to how much of the Montauk story predicted what would later be confirmed. MKUltra, the CIA mind control program, was real and involved similar experiments. Remote viewing was studied under Project Stargate. Time-based weapon theory is now a topic in certain DARPA circles. And maybe strangest of all, the creators of Stranger Things originally pitched their show under a different title, Montauk. The themes: psychic kids, disappearing people, government secrecy, and tears in time. So whether Montauk was a hoax, a half-remembered trauma, or a real program scrubbed from history, one question remains. If we could reach through time, what else might come through? Project Looking Glass. In the early 2000s, a former U.S. military insider, Dan Barish, began speaking publicly about a classified operation he claimed to have worked on. He said it was called Project Looking Glass. The purpose, to look into the future. But this wasn't science fiction. It wasn't based on guesses, statistics, or AI models. He said it was a physical device, constructed using advanced knowledge of space-time geometry and ancient technology recovered from archaeological sites in Iraq. It was allegedly stored underground, in a black site beneath the Nevada desert. The machine itself, according to testimony, used a series of rapidly spinning electromagnetic rings, focused through a field of water and controlled by highly specific resonance tuning. When activated, it would produce a visual projection, something like a holographic tunnel, showing possible future events, not predictions, possibilities, multiple timelines, branching outcomes, and how they might unfold based on decisions made in the present. Barish wasn't the only one to speak about it. Others, including Bill Wood, a former Navy SEAL, later claimed they'd been exposed to similar technology. He said the military used it during the Gulf War to determine enemy responses before they happened. But here's where the story takes a darker turn. By 2008, those involved said the device stopped producing multiple outcomes. No matter what variables were changed, no matter who sat in the room or what choices they made, it kept showing the same result. The same future. Something was coming, they said. Something fixed. A convergence point, an event that would occur regardless of intervention. According to them, this terrified certain groups in power, especially those who relied on controlling future narratives. If the timeline couldn't be steered, it meant their influence was ending. Some insiders described it as a collapse of systems, not destruction, but a loss of centralized control. They said it involved mass awakening, that people would begin seeing through illusions, political, social, economic, and choose autonomy over obedience. Others interpreted it as a timeline lock, the moment when quantum divergence ends, when all possible paths lead to the same destination. And so, Project Looking Glass was shut down. Not because it failed, but because it revealed something unstoppable. Critics, of course, call this pure pseudoscience. They say it's an elaborate fusion of Stargate fiction, ancient alien fantasy, and Cold War paranoia. But the details remain disturbingly consistent. Multiple sources mention the same convergence point. All agree it's centered around the early 2020s. All say the device was dismantled and buried. And all claim it was never about predicting the future. It was about controlling it, until it couldn't be controlled anymore. And now, years later, people wonder if something inevitable really is coming. Would we even know? The Moberly Jourdain incident. On August 10, 1901, two women, both highly educated, highly respected, and entirely rational, stepped into the gardens of Versailles. They did not expect history to meet them there. Charlotte Ann Moberly, principal of St. Hugh's College, Oxford. Eleanor Jourdain, her assistant. They were touring France together, stopping to see the Petit Trône, a small chateau on the grounds of the Palace of Versailles, once favored by Marie Antoinette. It was meant to be a leisurely afternoon. But something strange happened. As they approached the Petit Trône, they began to feel different. The air grew still. A kind of numb heaviness settled over them. They both described a sense of disconnection, as though they were walking through a stage set, not real reality. Then they noticed the people. Men in long green coats with tri-corner hats. Women in 18th century dresses. A man by a garden structure with a pockmarked face, who turned and looked at them with what they both called an expression of hostility. They didn't recognize the style of clothing. It wasn't French fashion of 1901. It was older. Then they saw a woman sketching on a stool by the terrace, pale blonde dressed in soft fabric. She didn't acknowledge them. She just sketched. Later, both women became convinced they had seen Marie Antoinette herself just before the collapse of the monarchy. Suddenly, a guide appeared, dressed normally, and led them out of the area. The atmosphere snapped back. The silence lifted, and everything looked modern again. They left the gardens disturbed, unsettled. Over the next few weeks, they compared notes, drew maps, and investigated the details they'd seen. They realized that some of the paths they walked no longer existed in 1901, but it existed in the 1780s. The layout they described matched historical records, not modern tourist routes. They also identified several of the individuals they had seen, matching their appearance and clothing to people documented in Marie Antoinette's court. They were meticulous. Neither woman was interested in ghosts or the paranormal. They weren't writing stories. They were trained academics. In 1911, under pseudonyms, they published a book, An Adventure. The response was mixed. Many readers found their account disturbingly plausible. Others dismissed it as a shared hallucination, the product of stress, heat, or overactive imagination. But skeptics had a problem. The story was too consistent. The historical details they described were obscure, details that weren't widely known in 1901 and hadn't yet been digitized or popularized. For example, their description of a hidden bridge used only by the royal household, something that hadn't been on public record at the time. When their identities were revealed, and it became clear these weren't mystics, but Oxford professors, the incident took on a new weight. To this day, the Moberly, Jourdain incident remains one of the most respected and perplexing alleged time slips ever recorded. There were no hallucinations, no visions, just a walk through a garden that shouldn't have led to the past. So what happened? A psychic replay of historical trauma? A localized temporal distortion? A fold in memory? Or in time itself? We don't know. What we do know is this. Two women stepped into Versailles in full daylight and found themselves surrounded by people who should have been dead for over 100 years. And when they stepped back out, everything was normal again. Project Pegasus. In 2010, a man named Andrew D. Basiago, an attorney and former child prodigy, made a public claim that sounded like pure science fiction. He said he had been part of a secret U.S. government program. It involved teleportation, time travel, and quantum displacement, and it was called Project Pegasus. According to Basiago, the project operated in the late 1960s through the 1970s under the U.S. Department of Defense Advanced Research Projects Agency. He said he was recruited as a child, around the age of 7, that the government believed children were more mentally and physically resilient to time travel than adults. Basiago described a series of experiments where he and other children were sent to various points in history using teleportation chambers, based on technology reverse-engineered from quantum field theory and possibly extraterrestrial sources. He claimed the technology was based on documents recovered from Nikola Tesla's estate after his death in 1943. The main method of travel was called a chronovisor, which combined electromagnetic fields with holographic imaging and resonance tuning, allowing not just the viewing of other times, but physical relocation. Some destinations were in the past, others were into the future. One of Basiago's most specific claims was that he witnessed Abraham Lincoln's Gettysburg Address in person multiple times. He said he was photographed at the event, wearing out-of-place clothing that made him stand out. He even pointed to an old photograph where a young boy stands awkwardly in the crowd and claimed it was him. In another mission, he described being transported to Mars via a jump room at a facility in El Segundo, California. He said he was part of a small group that included future President Barack Obama, operating under the name Barry Soetoro at the time. According to Basiago, these experiments weren't just scientific, they were strategic. The U.S. government was using time travel to gain intelligence advantages, viewing probable futures, transporting assets, and even planting information in past timelines. He said the government used this information to pre-identify future leaders, including himself. That he was told at the age of 9 that he would one day become president of the United States. And that the same was told to Obama. Critics, of course, dismissed his claims as delusional or performative. There are no declassified documents confirming Project Pegasus, no mainstream academic support, no hard physical evidence, but some things are harder to explain away. Besegago named real locations, real people, real offices. The places he described, including the Sandia National Laboratories and the Curtiss Wright facility in New Jersey, do exist and were involved in classified defense research during the Cold War. Others have come forward too. A man named William Stillings independently corroborated the Mars jump room story, also naming Obama and referencing secret teleportation technologies. Still, no independent verification exists. No evidence except the strange consistency of the testimony and the intensity with which it's delivered. Basiago never tried to sell a book. He wasn't building a cult. He simply stated what he believed to be true and filed formal legal declarations to have it investigated. To this day, he maintains that Project Pegasus was real. And if it was, then time travel isn't theoretical. It's not waiting in the future. It's already been done, tested, used, and buried so deep that most people will only hear about it the way we hear about myths, as stories that sound too strange to be real until we realize they always come with one missing detail, proof that it didn't happen. Flight 914. It was supposed to be a routine flight. Pan Am Flight 914, a Douglas DC-4, was scheduled to depart New York City on July 2, 1955, en route to Miami, Florida. It took off with 57 passengers and 6 crew members. Weather was clear. Communications were normal. Then, somewhere over the Atlantic corridor, it vanished. No mayday, no radar trail, no wreckage. After hours of silence, the flight was declared lost. Search and rescue teams found nothing. The incident was closed as a presumed crash at sea. Families mourned. Death certificates were issued. But on March 9, 1992, something impossible allegedly happened. A control tower in Caracas, Venezuela, received a radar signal, an aircraft appearing out of nowhere. It was approaching the airport, without clearance, on an outdated frequency. The tower attempted contact. The pilot responded, confused. He spoke English with a 1950s tone and phrasing. He asked, "Where are we? Is this Miami International?" The controller asked for identification. The pilot said they were Pan Am Flight 914 out of New York, due in Miami. On July 2, 1955, the tower, stunned, instructed him to hold position. As the plane circled, the controller noticed something bizarre. The aircraft was a Douglas DC-4, long retired from service. The tail number matched records of the lost flight. Through binoculars, they could see passengers, visibly distressed, dressed in 1950s clothing. Then, without warning, the pilot panicked. He reportedly shouted over the radio, "We're leaving." The engines roared. The plane made a hard turn, took off again, and disappeared from radar. Just like that, it was gone. Hours later, an airport maintenance crew claimed to find a small, outdated pocket calendar on the tarmac, marked July 1955. That story, published by Weekly World News, quickly spread across tabloids, conspiracy forums, and alternative news sites. Skeptics, of course, point out that the source was a tabloid known for fabrications. There were no official FAA records, no press coverage in major outlets, and no verified eyewitness testimony beyond anonymous or secondhand accounts. But the story won't die. It keeps coming back. It circulates in waves, especially after other strange aviation events, like MH370 or Cold War-era UFO encounters. Some theorists suggest Flight 914 flew through a temporal distortion, a kind of natural wormhole. Others believe it entered a government-controlled dimensional field, possibly as an accidental test subject. A few even claim the story was intentionally leaked, not as fact, but as a way to introduce the idea of time displacement into public consciousness, gently, because there's one detail people often miss. The tabloid never joked about it. They presented it as news, serious, direct, and consistent across multiple issues. And some readers insist it wasn't there. than it was. That even the publication history feels like a glitch. So is Flight 914 a hoax? Probably. But is that the real question? Or is it this: if one plane, just one, slipped forward in time and came back, how many never made it back at all? Victor Goddard's time slip. In 1935, Air Marshal Sir Victor Goddard, a decorated officer in the British Royal Air Force, had an experience he could never explain. It happened during a routine flight. He was piloting a small biplane from Andover, England, to Edinburgh, Scotland, when he passed over an old abandoned airfield near the town of Jourdain. He'd flown over it before. The place was derelict, overgrown with weeds, buildings collapsing, and no signs of activity. But on his return flight, something changed. He flew into a sudden storm, a violent, unforecasted squall. Rain hammered the cockpit. Lightning cracked around the wings. He struggled for visibility as his plane rocked in turbulence. Then, almost instantly, the sky cleared. He emerged into bright sunlight, but everything felt off. As he looked down, he saw the Jourdain airfield again. Only this time it was no longer abandoned. The tarmac was clean, the hangars were restored, and there were 4 aircraft parked below, yellow training planes he didn't recognize. He saw mechanics in blue overalls working on the planes. Not the brown uniforms the RAF used at the time. These were new, different. The colors, the layout, the personnel. None of it made sense. He didn't stop to investigate. He flew on. But what he saw stayed with him. Years later, in 1939, the RAF reopened the airfield at Jourdain. They restored the buildings. They began using yellow-painted training aircraft, just like the ones he saw, and they changed the mechanics' uniforms to blue. Everything Goddard described 4 years earlier became real. He hadn't imagined a future. He'd seen it. He wrote about the incident years later in his autobiography, Flight Towards Reality. By then, he had served in both world wars, had risen to the rank of air marshal, and had no reputation for fantasy or exaggeration. Goddard never claimed to understand what had happened. He never used the word time travel, but he said he had no doubt that he had witnessed something that had not yet happened, a literal glimpse into the future. His case remains one of the most well-documented time-slip experiences in modern history. There were no hallucinations, no illness, no trauma. Just a man, flying over a place he knew, and seeing what it would become years before it happened. Skeptics have tried to explain it as memory confusion or a misinterpretation of military developments. But the specific details, the exact aircraft, the hangar layout, the uniform changes were not public knowledge in 1935. Which raises the question, if time flows forward like a river, then how did one man fly briefly upstream? The Green Children of Woolpit. Sometime in the 12th century, during the reign of King Stephen, the villagers of Woolpit, a small farming community in Suffolk, England, encountered something impossible. 2 children appeared near the edge of a wolf trap, a pit dug outside the village to catch predators. They were a boy and a girl. They didn't speak English. They wore strange, unfamiliar clothes, and their skin was green. The villagers were stunned. The children were weak, clearly starving, and terrified. No one knew where they came from. They didn't speak the local language. They wouldn't eat anything except raw broad beans, refusing all other food for days. Eventually, they were taken in by a local nobleman, Sir Richard de Calais, who gave them shelter. Over time, their skin began to lose its green color. They learned English. Then the girl began to talk. The boy had died shortly after being taken in, but the girl, who survived into adulthood, explained what she remembered. She said they came from a place called St. Martin's Land. She described it as a twilight world, a place with no sunlight, only a permanent dusk. Everyone there was green and underground. She said they had been tending their father's livestock when they heard a loud sound, a kind of bell ringing, and suddenly they were somewhere else. They had wandered into Woolpit through an opening in the earth and couldn't go back. The villagers were baffled. Was it a children's story? A hallucination? A misunderstood metaphor? But the records are clear. This wasn't local gossip. The story was documented by two respected historians of the time, William of Newburgh and Ralph of Cajuste, all both clerics who wrote down events with care and clarity. Both agreed, two children had appeared. They were not from here. Some historians have tried to explain it. Maybe they were orphaned Flemish refugees, speaking an unknown dialect and sick from malnutrition, which could explain the green tint. Maybe it was folklore, exaggerated over time. But others point to the consistency of the story and the girl's strange memory of a world underground, of no sun, only shadow, and ask if she was making it up. Why something so specific? If it was just malnutrition, why did two children arrive together in coordinated clothing from nowhere? And why did no one ever claim them? To this day, there's no answer. Only a lingering question: if they weren't from a known country, if they didn't speak a known language, and if they came from beneath the earth, then maybe they weren't lost. Maybe they were sent. Time debt. Let's finish our video with a sci-fi story about time, where every second you borrow comes at a price you didn't know you'd have to pay. In the future, time isn't just money. It's the money. Not metaphorically, literally. Seconds, minutes, years. They're stored in ledgers, sold in markets, traded between people like currency. Want to live longer? Pay for it. Want to retire early? Buy a decade. Need to feed your child? Borrow an hour and pay it back with interest. In this world, every moment is owned. No one lives for free. The technology that made it possible is called chronosync, a fusion of quantum entanglement and neural storage. It tracks your lifespan in real time. It knows exactly how much time you have left to live, and more importantly, how much you owe. The richer you are, the longer you live. The poor die young, not because of disease or violence, but because they run out of time. Meet Silas. He wasn't born rich. He wasn't born anything. He was given 62 years at birth, the global standard. But life doesn't go according to schedule. His mother sold 15 of her own years to afford Silas's surgery when he was 7. She died at 38. Silas never forgot that. By the time he was 25, he was already in debt. Not money, time. He'd borrowed 5 years to cover student fees, 2 years to pay rent during a recession, and 1 year just to feel free for a summer he barely remembers. He didn't think about repayment. No one really does, until the collection notice arrives, a cold message, monotone voice, no threat, no anger, just truth. Your account balance is negative. 8 years, 3 months, 12 days. Please initiate repayment or surrender physical time to the state. He was 31, and he was about to be repossessed. In this system, there are only 2 ways to repay time. 1. Work for the state. They send you into high-risk environments, cleanup crews in irradiated zones, deep-sea repair units, neural test subjects. Every shift earns you seconds back. But the work is brutal, and time still ticks forward while you suffer. 2. Offer a younger version of yourself. They call it temporal reversal contribution. It works like this. Chronosync can rewind consciousness. You consent to have a portion of your life rewound and transferred into a debt recovery loop. You won't remember the loop. You won't feel it. But another version of you, a past you, is extracted and inserted into state service, running indefinitely until the debt is paid. Silas chose option 2. Everyone does. It's painless, invisible, forgettable, until it's not. The side effects started slow. He'd dream of places he'd never been. Wake up with cuts he didn't remember. See his own face on news footage, doing things he never did. At first he thought it was paranoia, glitches, data corruption, but deep down, he knew. The state doesn't just rewind your mind, it copies it, sends it back. And when that version of you begins to act, it can ripple forward, not as a ghost, not as a memory, but as a forked reality, bleeding into your own. One day, Silas woke up with a tattoo on his forearm. 3 dots, black ink. He didn't put it there. He asked a friend. They said he'd had it for years. He searched records. Nothing. He checked surveillance footage. In one clip, taken years ago, he watched himself walk into a building he's never seen. Inside, a state labor office. In the video, he's smiling. The more he looked, the less his life made sense. Photos had changed. People remembered conversations he never had. He'd receive phone calls where strangers apologized for things he didn't understand and hung up crying. One night, he found a note on his door. It was in his handwriting. "Don't look for me. I volunteered early. I thought it would save you. I was wrong." That's when the truth clicked. There wasn't one copy. There were many. Every time his debt increased, a younger version of him was pulled, over and over. A child Silas working in extraction fields. A teenage Silas recruited into neural defense. A college-age Silas recycled through endless test loops. And now, fragments of all of them were leaking back. He wasn't a man anymore. He was a collage of broken selves, each one trying to repay the time he never meant to borrow. The arrow of time. You wake up, eat, work, sleep, repeat. Every second ticks forward. Never back. No matter what you do, time moves one way, toward the future. But why? Why does time only move forward? Physics tells us the fundamental laws of the universe, gravity, electromagnetism, quantum mechanics, are time-symmetric. They don't care whether you run the clock forward or backward. A pendulum swings the same either way. A planet's orbit follows the same math in reverse. In theory, nothing in the equations prevents time from running backward, and yet it doesn't, not in real life. You remember the past, not the future. You grow older, not younger. A cup falls and shatters, but never reassembles itself. Time has a direction. We call this the arrow of time. But where does that arrow come from? There's one answer physicists keep returning to, and it all comes down to entropy. Entropy, the engine behind time's arrow. In simple terms, entropy is the measure of disorder. The higher the entropy, the more chaotic and randomized a system becomes. A hot cup of coffee cools down. Ice melts. Buildings decay. Memories fade. Every natural process moves from low entropy to high entropy. And once it increases, it doesn't decrease on its own. The coffee doesn't reheat itself. The broken egg doesn't reform. This is the second law of thermodynamics, one of the most solid, unbreakable rules in physics. And it's the best explanation we have for why time moves forward. Because entropy only increases. That's the direction the universe is going, from order to disorder, from structure to chaos. Time flows in the same direction as entropy. That's not just philosophical, it's physical. You can't unmix milk from coffee. You can't unscramble an egg. And on a cosmic scale, you can't reverse time, because that would require reversing entropy. But why did time start moving forward in the first place? Here's the weird part. If everything in the universe tends toward disorder, then something must have started it in a very ordered state. And that's what scientists believe happened at the Big Bang. The early universe was shockingly low in entropy. It was hot, dense, and uniform, but incredibly ordered. Since then, it's been expanding, cooling, and becoming more chaotic. Galaxies formed. Stars exploded. Life emerged. Disorder increased. Entropy rose. And so, time moved forward. The reason we can't go backward is because doing so would mean undoing the entire direction of entropy, reversing the expansion of the universe, reassembling broken stars, unscrambling the entire cosmic mess. Which brings us to the philosophical side of time, the role of memory and perception. If the laws of physics don't prefer a direction, and if time is just entropy increasing, then why do we experience time at all? The answer lies in memory, and the way our brains organize cause and effect. You remember what happened yesterday because it left a mark, a pattern in your neurons. You don't remember tomorrow because those marks haven't been made yet. When you light a match, you see cause and effect. You strike it, it burns. But what you're really witnessing is entropy, the conversion of chemical energy into heat and light, from order to disorder. You interpret that change as the passage of time. So in a strange way, your experience of time is not time itself, it's your mind's way of tracking entropy. Could time ever run backward? In theory, yes. If you could reverse entropy, you could reverse time. But doing that would require perfect control over every atom in the universe. You'd need to rearrange the cosmos, down to the last photon, back into its original low-entropy state. No known force can do that. And even if it were possible, your brain would reverse too, meaning you'd forget the future and remember the past. You'd still feel time going forward. Even in reverse, you'd think it was moving forward. That's how deep this illusion runs.